Hello, good evening.
Good evening.
Ma'am, the voice is not audible, ma'am.
Actually, I haven't spoken yet. Now it is clear?
Yeah, ma'am.
Yeah, just 1 minute.
It is not audible, sir.
Yeah, just 1 minute. So, good evening, everyone. Am I audible clearly now? Hello.
Yes, ma'am.
Yeah.
Yes,
So,
ma'am.
so here's a question. So in this question, you have given the graph of function. So based on the graph, you have to find out at which points the function is continuous and at which points the derivative of function, that means the function is also differentiable. Okay. So I'll giving you 5 minutes. Try it out, then we will discuss this question. Okay. Good evening, Suraj. So just try this question, then we will discuss. It's a good example. If you got the answer, just reply yes in the chat box. Okay, so it was covered by our picture already.
Yes, ma'am.
Okay,
In
Yes,
the
ma'am.
morning.
okay,
Yes,
so
ma'am, but I have the doubt in the question. So we
okay.
can discuss at the last. First,
Yeah, sure.
the revision session.
Okay, fine.
Yeah.
Got it. So if it was discussed, then there's no need to discuss. Okay, so this is a revision session for you. So we'll go through the major topics. First of all, start with the function, and this week, this 5th week, start with the composition of function, right? So you learn what is the composition function, and then you learn how to compute its domain and range and how it look like. Okay, so everyone is clear with the concept of function. What do you mean by function?
Ma'am, can we practice some questions, because concept is clear, but when we look at the question, we don't know what to do. At least I don't know what to do.
Okay, what type of question? I mean, you're asking for
In
finding
this
domain,
area,
or
yeah, finding range especially, right? Finding range gets complicated in
yeah, actually finding range of a function is a bit hard, because when you can easily find the domain of function
right,
by observing the expression of function, right?
right.
But finding the range of function will involve so many different concept. So if you have polynomials, then you know what is the range of the function. It always will be the real number, right?
Yes, ma'am.
Yeah. So for finding range of a function, you need lot more things. I mean, for example, if the graph is given to you, then it is easy to find, right?
Yes, ma'am.
Yes,
Suppose this is the graph of function,
yes.
then
Right.
you know, and if I'll say that this line is the asymptote of graph, and this below line is the asymptote of graph, and I'll say that this graph is not crossing this line. Suppose this line is something y is equals to 5, and this line is something y is equals to minus 5. Then from the graph, you get some idea, okay, the range of function is from minus 5 to 5, right? You
Yes,
have
ma'am.
seen any specific question for finding the range? Because range, for
In
finding
a
the range.
composite function, ma'am, in a composite function, when we have f of g, h of g, and like that,
Okay.
right? Can we solve some of those problems? Because from any paper, anywhere, right? So any sample would be fine. Just
Okay.
so that we can practice something.
Yeah, sure. You're clear with the domain of composite function, right? There you
Ma'am,
don't have any doubt?
ma'am, for normal function, like even in logarithm, it is, I mean, I'm able to find the domain, but if the function is like quadratic with added logarithmic function, it is hard to find domain.
Quadratic function, you mean which type of function? I mean, if it is a quadratic
I
function.
can give you a
Yeah. Just give me a question. Actually, range of the function, I mean, we haven't talked about range of function, right? I mean, in the lectures, we also define what is the domain of function. Range of function for specific function. I mean, you know what is the range of exponential, e to the power x, a to the power x, log base, a of
No,
x, right?
no, ma'am. For when we go for composite functions, right? F of g.
Yeah. Okay,
So we
fine.
have to determine what is the range of g, because that
Yeah.
becomes the domain of f. So that is where, so that kind of problems, if we
Oh,
can solve.
okay. Now I got it. What you mean? Fine.
ma'am, can I tell the question?
Which question?
Yeah, there is a question in which there is a quadratic equation and a logarithmic, and you
Uh,
have to find the domain.
so you can able to write it the expression in the chat box, or rise hand
I can tell you, you can write.
Okay. Just tell me, I'll write it down.
So 3y 9 minus x square
3 by 9 minus x square
plus
plus
log to the base 10
log
to the base 10
base 10
of x cube minus x.
x cube minus x. Okay, so here you have two function. First function is this f1 of x, and then you have second function, this function. This is f2 of x. Right? You want to find the range or the domain of function?
Domain.
The domain of function, right? Okay. So just observe this thing, that this function has domain. What is the domain of this function? It's
I
easy.
mean 3 and minus 3 will not, because
All real number
because-
except 3 and minus 3.
yeah, correct.
Yeah.
Plus minus 3. And what is the domain of this function?
I mean, the x cube minus x should not equal to 0.
Yeah, x cube minus x. This should be strictly greater than 0, right? So that means that
Okay,
our
I
x
have
cube.
done here. I've done wrong. I've actually equated it not equal to 0.
Yeah. So you have to remove all those finds where x cube minus x is not equals to 0. Plus they should be strictly greater than 0, not less than 0. Okay.
Okay, so the both of conditions would be applied, right?
Yeah, both condition, because when we define log base a of x, we need x to be strictly greater than 0, right?
Okay,
We are not able to define, because this is the graph of log. You can remember the graph of log. This is the graph of log when a is strictly greater than 1, right? So here, or when a is less than, this is the graph of log. So in any of the situation, we are not able to define what is the log in the negative real axis, right? This part
Yes.
we cannot define log. So you should also take this condition in mind.
Okay.
Till now we haven't discussed any question. I'm just asking what are the concepts.
Ma'am, can you proceed with this question?
Okay, so first of all, where your x cube minus x is equals to 0. So it's just simply x square minus 1 is equals to 0. So that means your x should be plus minus 1 and 0, right? Okay. So from here you get some intention that, okay, fine. From this, if my x is also strictly greater than 0, even though this x cube minus x, if you observe this thing, that this x cube minus x, this is something, some sort of increasing function, right? I mean, if your
Yes.
y is, suppose you have some quantity, suppose your a is less than b, then you know that a cube is less than b cube, right?
Yes.
But it is not. Okay, fine, it is not increasing. If it is increasing, then we can easily solve it. But then for this condition, you have to look out something like that, x square minus 1. I want this to be strictly greater than 0, right? So you know what they call it, the wave method for finding such type of thing.
Yeah, on the number line.
Yeah, so you plot the roots. So roots are -1, 0, and 1. And since the sign is positive here, so start with positive, negative, positive, negative. And I want greater than 0. So that means these are my required set of points. You know this thing?
I know, but before
Not
putting
audible.
positive. Yeah.
Yeah,
Right
so
now,
that means your x should belongs to open interval -1, 0, union with 1 with infinity.
Ma'am, actually, this one you put the plus minus on the number line. So, before putting, you must check, na. I think if the number more than 1, then we should put number more than 1 in the equation,
Okay,
and if
okay,
it is
okay.
positive, then
No,
positive.
yeah, whatever you're telling is true, but this is called wave method. Actually, what happened? Okay, in case if you put, suppose you put 2 here. Okay, so this will be 2, 2 minus 1 will be 1, and 2 plus 1 will be 3. So it is 6, so it is again
Positive.
0. Yeah, right. But this is called wave method. Actually, you don't have to put 2 or something. This wave method itself tell, okay, so whatever points will lie, I mean, whatever points will be ahead of 1, then your expression is positive. And yeah, so this method is helpful. If you want, we can simply discuss it for linear function for finding the domain. Yeah, Wavy curve method, correct. Now you got it?
Yeah.
So in general, what happened now? If, okay, fine. So let's at least discuss it. It's always, please go sequentially, like briefly discuss concept and take questions on that. Okay, so now we have, sorry, someone was saying something?
Yeah, ma'am, what you are exactly discussing?
Sorry, what?
Ma'am, what you are exactly discussing is
Actually,
just...
some people have doubt in something, so that's only thing we have discussed till yet. But okay, fine, I'll go sequentially so that no one will get confused. Fine. So first is composition of function, right?
Ma'am, you still left the question. Please continue with.
Yeah, just I'll just go with the domain, whatever he asks. Okay, so suppose you have to compute the domain of F composite G. Then as I said, what you have to do, first compute the domain of G, right? And then domain of G and domain of F. Then you know that the domain of F composite G will be the subset of domain of F, domain of G. And you have to subtract those points where, okay, subtract all those x where f of g of x is not defined. So that means you have to minus all those x belongs to domain of G such that g of x does not belongs to domain of F. That's what you have to do for finding domain of F composite G, right? So here also you don't have to find about range. Yeah, fine. Whatever doubt you have, we'll take it. First, we go through the content, then we'll discuss it. Okay. So this is how you find the domain of F composite G. But here is this condition. So this condition may you think that you have to find the whole range of G, but that's not the case. First, you will go for the domain of F and then try to find out. Okay, so suppose G cannot have such points. Okay. And it is easy. I mean, we won't give such complicated thing that won't be observative, right? You don't have to go for the range of a function fully. If range is, if the function is complicated, it's very tough to find the range of any function. So now now your doubt is clear. Let's ask. Someone asked about range of the function, right?
Yes, ma'am, I did.
So you got it now. You don't actually have to go for the range. You just find out, intuitively you can observe that what are the gx which are not belong to domain of F. Then you just have to remove them.
Ma'am, can you repeat this second point, ma'am? Basically, first you have to find the domain of both the functions exactly. Then for the domain of the composite function, we have to find the domain of G. Minus what you have written, ma'am, is not clear.
Minus all those, you have to minus from domain of G. You have to minus all those x from domain of G. What I was saying that this is second point. For second point, what you have to do, that from domain of G, you have to minus all those x belongs to domain of G such that your g of x does not belongs to domain of F. Now you got? That means
Yes,
your f should belong, your f should define on g of x now. So if f is not defined on g of x, then how would you define F composite G, right? So that is my point. So for this point, you don't have to go for the whole range. I mean, you intuitively will know that, okay, fine, this is the point, x such that this g of x won't belongs to the domain of F, because there are only 1 and 2 points will missing. It's not always. Now you got it?
Yeah, ma'am. Yeah.
Okay. Fine.
Ma'am,
Yes.
ma'am, there's only one revision class for quiz 2.
Sorry, what?
Ma'am, there will be no class for a revision session of quiz 2 tomorrow.
Actually, I don't know. They have scheduled in your calendar. Is there any class?
No, ma'am, it's not there. But generally, we have on Friday morning.
Okay, so
And
you
we-
guys want a class revision session?
Yes, ma'am.
Okay,
Ma'am,
so
I think we need problem solving sessions.
you need
Yes, ma'am.
problem.
With the revision, we need some questions.
I
yeah,
think
ma'am, generally that
the concepts
Shall sir discuss questions which are generally related to the quiz 2, like quiz papers. So that session is very helpful, and sir generally take one session before every quiz. But
Okay.
previous year questions will be
So,
fine.
yeah.
no, it's
PYQ
generally the
session.
questions, not PYQs, but the questions are similar to the quiz questions. So
yeah, now I get it what you want. Okay, fine. So actually, this is the revision session before the quiz. So actually, I also supposed to do those things only. So let's just go one by one. So now, okay, fine. So we'll discuss it later. That if after this session you also have doubts, then we'll take some PYQ session. Okay. So don't worry about that. Just concentrate here. Okay. Now, so domain of composite function is clear to you, or you want some examples also? I mean, you can
We
solve
want
some
some
examples.
examples. Yeah, we want some examples, ma'am.
Okay. Just 1 minute. I'll just open.
So ma'am, I think
Yes.
somebody gave that question, right? The previous question wherein we had to find the domain.
Yes, ma'am.
Yeah.
You should continue with
This question, right?
Yeah.
Okay, so you want to, okay, fine. So just
Actually,
discuss.
I have done this, but I didn't got the right answer. I was close enough, but I didn't got the right answer.
What answer did you get?
I was getting from, I mean, I plotted every point like -3, 3, and 1,
Oh,
and I was getting from -infinity to 0, and then 1 to
no,
0.
that's not the correct approach. Okay, just let me
So I think
introduce something.
uh,
So this is the sum of two function, right? Okay, this is log of x cube minus x, right? So whatever domain you will get, so that for that domain, both of the function should satisfy that. For this log of x cube minus x, what we'll get? We get our x belongs to this thing, right? So that means for this, I get my x belongs to -1, 0 union with 1, infinity, right? And for this, what I'll get? That my x belongs to r minus plus minus 3, or simply this can you can write in this way, right? Minus infinity to -3, union with -3 to 3, and then union with 3 to infinity, right? Correct? This is clear?
yeah, this is clear.
Yeah, so then whenever you have to find the domain of some summation or because this is somehow, if you put an x, so then you will put those x in this function also and this function also. So that means at that x, both of the functions should well defined, right?
Yeah, so
yeah,
I think
so you
should
have to take the intersection of these two sets. This is your S1, this is your S2. So the domain of function will become S1 intersection S2. Now it is correct? It will match to your answer or not? So what will be the domain?
Yeah, but I was not able to find the right intersection.
Okay. Yeah, so this is not that much intuitive. I mean, you have to go through both. First of all, you have to check both condition, and then you have to observe something. Okay.
Can we do this through number line?
Sorry, what?
Can we find the intersection through number line?
Yeah, you can find the intersection. That will be more easy. I mean, just plot your points and try to, mark it down, whatever the intersection point is.
Ma'am, so that is the problem. I'm not able to do that. I have a confusion in this.
Okay, so you want to find the intersection of these two sets?
Yes.
There you have confusion. Okay, fine. So do that. Not quiz related actually. I'll discuss the concepts which are in 1 or 2 questions and not mainly so many questions. But yeah, if you guys just as you guys are telling me that you are familiar with the concepts, then we can jump to the questions only. So there also I can explain some of the concepts. Composition function. Okay, so I'll give one example of domain of composition function. Just try to solve it, okay? So find the domain of and the option also for the question. Okay.
Ma'am, what is the answer to the previous question?
So the answer will be the intersection of these two. So intersection will be from here you get minus infinity to minus 3. But these points are not here, right? Then you get minus 3 to plus 3. But here we just have minus 1 to 0. So again, we don't have, I'm sorry, this won't be the answer. So again, we don't have from minus 3 to minus 1 points are present here, but they are not here. So this is minus 1 to 0, right? And then union with, we don't have up to 0 to 1 here. We do have up to 0 to 1 here, but that won't be the case. Then we have 1 to 3 here and 1 to 3 here. So again, this is 1 to 3. Then we have, then we are missing 3. So then this is 3 into infinity. This you can simply write down on the real line and try to, try one pen, use the blue pen to insert those intervals and then find out what is the intersection of this one. So this should be the answer.
Excuse me, ma'am.
Okay, thank you.
Yes.
Ma'am, I'm telling you, ma'am, that's the thing that I have in doubt. I'm not able to find the intersection between the both of the sets. So can you please do this?
Yeah. Just 1 minute. I will give questions to others so that they won't be.
Okay.
Yeah.
Ma'am, are we going to solve PYQ's questions also for quiz 2?
Sorry, what? Yeah, we will discuss similar. I mean, I don't say similar. I'll just say we will discuss whatever the concept are going to ask in quiz 2.
Okay, ma'am. Okay, thank you.
Yeah. I mean, not similar. Yeah, someone pointed out this question that consider the function fx is this, dx is this, x, the function defined by and its domain. Actually, it is a bit difficult, but this question I have already given in.
Ma'am, I have also one doubt.
Yeah.
What is the syllabus of quiz 2? It will be
Quiz
after
2
week
syllabus
5.
is, sorry, what? Someone saying something?
It will be after week 5.
No. It won't be after that thing. I mean, we have discussed. Okay, so you guys should know all the concepts from the week 1 till week 8. Okay, it's not the case now.
Okay, ma'am. Thank you.
Okay, so you guys are posting some question. You want to discuss those? Fine, we can find out what is the domain. Okay.
Yeah, ma'am. Good evening, ma'am. Actually, ma'am, what I'm saying is, ma'am, if you first complete the concept once again, ma'am, then we do the question session, ma'am. That will be more useful, ma'am, because the concept has been recapitulated, ma'am.
Okay, fine. So
Once
that
you, ma'am,
is
systematically, yeah.
Yeah. Okay, fine. Just give me half an hour. I'll just quickly go through the whole of the content, and then we will discuss what is the. That was my plan. That I will go through the contents once again, and then we will able to we will solve some questions. Okay.
Yeah, ma'am. You start for the beginning, ma'am. Just recapitulate all the concept, ma'am. Then we can have the question section.
Yeah. Okay, fine. So that's why I'm talking. So your week 5 start with the composite function, right? Here you will try to find out what is the domain of composite function and how to define the domain of composite function, right? So this is the first thing you have learned, and I don't think anyone want to recap of this because I already did it. Okay, so just leave it. Now second, we will discuss what is the exponential function. Okay, so exponential function is of the form a to the power x, where we give some condition on a that our a should be strictly greater than 0 and our a should not equals to 1. Okay, so then we will divide exponential function into two parts, that a to the power x when our a lies between 0 to 1 and a to the power x when our a is strictly greater than. Okay, in exponential function you just have to remember what is the graph of function. The graph of function will tell you the every property of the exponential function. This is the graph of exponential function for case when a is between 0 to 1. And this will be the graph of exponential function when our a is strictly greater than. What is the y-intercept in this case?
1, ma'am.
1.
1.
Yeah, 0, 1. And similarly, the y-intercept in this case is similarly 0, 1, right? Okay. So whenever you have exponential function, you know that the graph of exponential function will look like this. Okay. So from this graph, you can easily tell what is the end behavior of exponential function and what it is. In this case, it is decreasing. In this case, it is increasing. And as x goes to infinity, in this case, we approaches to 0. And as x goes to minus infinity, we approaches to plus infinity, right? Similar things are happening here. If x goes to infinity, we approaches to plus infinity. And if x goes to minus infinity, we approaches to 0. Okay, so these much are the exponential function. Then you know some basic property of exponential function, that a to the power r into e to the power s is a to the power r plus s. And a to the power r to the power s is same as a to the power rs, and so on, right? So these are the basic concepts about exponential function. Sorry? Okay. Now we go for logarithmic function. Okay. So we know that log base a of x is equals to y if and only if a to the power y is equals to x, right? So for defining log, we want some inverse of exponential function. So we take that function to be log, which will evaluate the inverse of exponential function. Now here, when we define log, then we should always remember what is the restriction on the base and what is the restriction on the domain. So we always want our x to be strictly greater than 0, because you can observe here that the range of exponential function are always positive real numbers. So that's why we want x to be strictly greater than 0. And also we want our a should not equals to 1. And our a is also somehow strictly greater than 0, right? So this is the basic condition for defining the log. Okay, so then only your log base a of x will define. Now similarly, we have graph of logarithmic function. If your base point is lying between 0 to 1, then the graph of logarithmic function look like something like this. And the x-intercept is 1, 0, right? And it is again decreasing function. And similarly, using the graph, you can easily check the end behavior of the logarithmic function. Similarly, if your base is strictly greater than 1, then we know that the graph of logarithm will look like something like this. Here also the x-intercept is 1, 0. Okay, so again, this is an increasing function, and this is a decreasing graph. This is an increasing graph when your a is strictly greater than 0. Strictly greater than 1. Okay. Then we have discussed some properties of log, which are important. So first property is that log of m plus log of n, log base a of n is equals to log base a of mn, right? Am I right or wrong? Similarly,
Yes,
log
ma'am.
base a of m,
Yes,
if
ma'am.
we have minus, then we have log base a of m by n. And then we have this property that log base a of x to the power n, then the m will come out. So this is n log base a of x. So these are three properties. Then the main property is the change of base. That means if we have log base a of x and I want to change my a by some another base b, then what we'll do? So this is log base b of x upon log base b of a. Okay, so this property tells us that you don't have to look for all the logs. It is enough to look for two logs. First is log base 10 and second is log base e. So log base e is known as the natural logarithm, and it is also denoted by ln of x. If it is log base e of x, then it is simply ln of x. So if you saw somewhere ln of x, then you should know that this is nothing but log base e of x. Okay, don't get confused in the exam if you find out ln of x then. Okay. So these are the major properties of log. And for if you get some complicated expression in this thing, that if you have suppose log base 10 and here if you get some function fx, then how to find the domain of this log, this function? you just have to find out two conditions whenever you are where your fx is equals to 0, and your fx should strictly greater than 0, right? So just try to find out where your fx is equals to 0, and then you can easily check that what are the points where your function is strictly greater than 0 or less than 0. Okay, so here also you somehow, in some manner you have to deal with the range, but we won't give such a complicated function which are not observative. Okay, there is slightly changes in the function, but you can easily, by doing some computation or factorization, you can easily got those things. Okay, so don't worry about that. Okay, fine. So this is the log, and after the logarithmic function, I think we jump to the continuity, right?
Yeah.
Correct.
I think sequences.
Yeah, sequences are okay, fine. So that means if you given sequence an, so this is something like a list of numbers. You can say that a1, a2, a3, and so on. So then you say that this sequence converges to a number a if, as we move along n goes to infinity, then our ans should get more closer and closer to a. That means if I'll take any ball in a around the point a, then there should be an an sitting here. Okay, if I'll take again smaller ball, then there should be an. So that means if I go till infinity, as n goes to infinity, then my ans should get more closer and closer to a. That is the meaning of limit. Okay, so this is the sequence.
Ma'am, sorry to interrupt you, ma'am. Actually, your
Yeah.
writing is getting confusion, ma'am. Sometimes infinity looks like something it's different, ma'am. NX, ma'am. Can you speak, ma'am, little? Your writing, can you speak, ma'am, little bolder, ma'am, so that we'll be able to get you properly.
Okay. This one. Yeah.
Yeah, ma'am. Can you repeat, ma'am? If you write it, ma'am, little bold and ma'am, little slow, ma'am, then it will be clearly, eloquently visible,
What
ma'am.
I was
Basically.
saying that our an the sequence converges to a as our n goes to infinity. But I'm saying that as we move towards a, suppose we are moving towards a. Okay, suppose this is a path and we are moving towards a. So as our n goes to infinity, our ans should reach to
A.
That is my meaning. I mean that we should get more closer and closer to a. That point we will define as a limit of a sequence. Okay, that is my interpretation. Suppose you have this sequence that -1 to the power n. Okay, so what is the limit of this sequence?
-1.
Yeah, there are two limits, +1 and -1. Because what is the sequence? The sequence is nothing but if I start with our
Absolute.
n belongs to natural number which contains 0. So then this is 1 -1, 1 -1.
Auxiliary series.
Divergent, I guess.
Yeah. So
Yes,
it is
divergent.
divergent. Yeah. So that means it won't get closer to any one, single point, right? It is not able to go into a single point. So that's why it is not convergent. It has a limit points, but it is not convergence because it is not going to a single unique point. That is the point, right? Because as our n goes to infinity, it is possible that we can get +1 and -1 both. As our n goes to infinity, we are always jumping between plus and -1. We are not getting a single unique thing which we get more closer and closer, right? So that's the thing here. So this is it's not that much worry about sequence of limit of a sequence. Simply for
Ma'am, am I audible?
Yeah.
So what is the relation between the limit of sequence or convergence of sequence?
Convergence of a sequence means you should get a unique limit.
Okay.
So here we are jumping between two numbers now. We are not getting closer to a single number. We are jumping between +1 -1 +1 -1. So that's why this sequence is not convergent. Okay.
Okay. So the limit, what will the limit?
Actually, I'm saying limit in some other sense. There is some other concept of limit, but for your sake of knowledge, you just say that this sequence is not convergent, this sequence is divergent. Okay.
Okay.
You for
If the sequence is divergent, then it will not have a limit.
yeah, it will
Okay.
not have a limit. But here, if we go to I mean, if our n goes to infinity, we come across either +1 or -1, right? So in that sense, also some people will say these are the limits. So just don't bother about it. You should get a unique limit. Okay, that's what I'm saying. I mean, you should go to a single point much closer and closer as your n goes to infinity.
Okay.
Okay.
So then it will be convergent and also have limit.
Yeah, unique limit. Okay. So this is for computation of sequence. There is one thing I want to tell you, that suppose you have to find out what is the limit and tending to infinity of two sequences an upon bn. Suppose they have asked you this type of question. Okay. So now, and your an is some polynomial of n, and your bn is also some polynomial of n. Okay. So in this case, what you will do, you just factor out what is the greatest degree of n from both of the numerator and denominator. For example, if my an is some n cube plus 7n plus 8. So this is my n cube plus 7n plus 8. And this is my bn. Suppose some n to the power 7 plus 11n plus 9 or -9, something like this. Okay. So if you have given such type of question that you have to find and find the limit and tending to infinity of these type of question, then what you will do, you will factor out what is the largest degree of n from the numerator as well as from the denominator. Okay. So in the numerator, what is the largest degree of n? Hello.
7.
In the numerator,
3.
Right. So we will factor out n to the power 3. Then what will remain here? That 1 plus 7n square
7
plus
x
8
square
n cube.
x cube.
Right. N cube. Okay. And from the denominator, this is n to the power 7 is the
7.
largest. So we'll get factor out n to the power 7. We'll get 1 plus 11 by n to the power 6 minus 9 by n to the power 7. Then we will cancel it out. Okay. So this will become limit n goes to infinity. This will become that 1 by n to the power 4. And we have something here. Okay. Now, if you apply n goes to infinity on this factor, you observe that this thing goes to 0, right? 1 by n to the power 4
Yes,
will go to 0 as n goes to infinity, correct?
Yes, ma'am.
Yeah. And this part, that 1 plus 7 by n square plus 8 by n cube, as our n goes to infinity, this goes to where? This
1.
part 1, right?
1.
Similarly, this part will also go to 1.
1.
So that means what is the limit of our sequence? 0 into
0.
1, which is again 0. So this is the method for computing the limit if you are given an by bn, where a and bn are some polynomials of n. I mean, in general also, if you have given something that limit x goes to infinity and some px by qx, what you will do, you will factor out the largest power from the px and qx both, and then do the computation. Okay. This is a one, I mean, method to do it. It's easy, right?
Yes,
Yeah.
Ma'am,
Any doubt? Yeah.
what if
Yeah, what if
okay,
the n will I mean, what if suppose, so this is a one case where we are getting n in the denominator. Okay. Now suppose this thing, that if you want to calculate limit n goes to infinity of, I am simply taking n cube plus 2n plus 1, and here we have n plus 1. In this case, you do the same thing, that you will factor out the largest power of n. So this will become n cube plus 2 by n square plus 1 by n cube. And then n is 1 plus 1 by n. What you will get? You will get limit n goes to infinity. This is n square. And there we have something. And here we have 1 plus 1 by n. So now if you apply n goes to infinity, this will become infinity into 1, right? So the answer will be infinity. Correct?
in the previous example,
Yeah.
can you scroll up?
Yeah.
Like what if we take common as n to the power 7 from the numerator?
If you take common n to the power 7 from the numerator, then you will get here n to the power 4, right?
Yeah.
So then this whole term becomes 0, right?
Okay.
Yeah, and this term become 1. Again, the answer will be 0 only. I mean, 0 by 1 is well defined, it is 0, right?
Yeah,
That's also fine. But this is not the universal thing. I mean, if you are generalizing it, so the general method is take take the largest power common and factor it out and then decide what is the limit. That will
okay,
be
okay, ma'am.
much more easier and applicable in every cases if you have polynomials in n or x.
Okay, ma'am.
Okay.
Ma'am,
So
ma'am,
now, yes.
can you a bit explain a subsequence?
You don't have subsequences, right?
No, ma'am. In previous year questions, there is a lot, 2 or 3 questions, I think, from subsequence.
About subsequences.
Yes.
Okay. I mean, subsequence is some other topic, but
Ma'am, if you scroll up the last question that you solved here,
yeah,
it's infinity, so it is non-convergent, right?
yeah,
There's
it
no
is not gonna. It goes to infinity.
so that means there's no limit.
Yeah, there is no limit for this sequence. n by bn.
Thanks.
Yeah. They have put some subsequence question. Okay. Subsequence are basically what if you have a sequence an. Suppose you have a sequence an. It looked like something a1 comma a2 comma a3 comma and so on. Then you just pick some randomly ais. Suppose I will pick a7, a9, a11, a13. I mean, I am picking the odd numbers, right? Suppose a1, a3, a5, a7, a9, a11. In the similar fashion I will do, this will become a subsequence of the sequence. Subsequence. The name will suggest itself, right? Subsequence. That means the subfamily of the sequences, right? So this is the basic definition of sequence, that we are just picking out some numbers from the sequence and together we are forming a sequence that will call the subsequence. Now here fact is that okay, they are in order. I mean, it need not to be always in order, but yeah, it is not always in order. It never be in order. You can take any choices, whatever you want, because okay, then I have to go more deep for the subsequences. Actually, what happened? This long break, what is it could be fluctuating. Yeah, so what I'm saying that you have to take in any order, but you won't able to come back. I mean, once you have chosen, suppose I have chosen a1, a3, then I won't come back and choose a1. This is not possible in subsequence, right? If we have chosen a1 and we have then and after that if I choose a3, then I should go forward, not come backward. Okay, this is a one thing. Yeah, correct. So in you guys getting what is the subsequence of a sequence?
Ma'am, can you give one example?
Ma'am, actually, the question is a bit tricky in the previous year.
You just post it out, we will discuss it.
Okay, okay, ma'am.
Post the question, then we'll discuss. For example, if you have a sequence an, is this is your sequence. Suppose 1, 3, 5, 7, 9, 11, 12, 13, 14, 15, 22, 24, something. This is a random sequence. Okay. So if I want to find a subsequence, what I'll do, I'll pick randomly numbers, whatever I'll choose. Suppose I'll choose 1. So this will become 1. Then I'll choose 7. But here observe that if I'll choose 7, then I'm not allowed to choose 3 or 5. That means there is no allowance for choosing the numbers which are which are previous from the chosen number, right? You can assume that. Then suppose if I'll take 12, this will become 12. Suppose I'll take 14 and 22 and so on in the similar fashion. So that means
And
what I'm doing, yes.
And I cannot repeat 12 again, right, ma'am? So 12
Yeah, you cannot repeat 12 again. This is chosen. So it's gone. If there is some quantity n which is again 12, suppose I have 12 in the sequence again, it is possible, right?
Yes, yes. In
Then I
that
can
case,
choose this 12, but I cannot repeat this 12.
right.
Yeah, so this is called the subsequence of a sequence. Actually, it is more defining in the mathematical sense, but that will confuse you. So that's why I'm giving the interpretation.
Ma'am, I have sent the question. Can you please?
Yeah. So you got the sense of a subsequence, right?
Yeah.
Everyone, there's any doubt for anyone?
No, ma'am.
Okay. there exists two convergent sequence A and Bn which converges to two different non-zero real numbers, but A equals to 0. Sequence A is okay. Okay. So everyone is get the intuition what is the subsequence means. You have to choose randomly pick some elements from the sequence and make a new sequence. But there are two restrictions. First, you cannot choose the element which are already which are before the chosen number. For example, we cannot choose 3 and 5 in this case if I will choose 7. And the second thing is that you cannot repeat the chosen number. Okay, so these are the main point. So this is a question he have posted. Shubham has posted. Okay, so this is a subsequence. Now there is a fact. If you have a sequence an and your sequence converging to A, then any subsequence of an will also converge to A. This is a fact. Okay, so just try to interpret it. The proof is not that trivial. So if you have any sequence which converges to some point A, then if you take any subsequence of that sequence, that subsequence also converges to that point A. Got it? Now here we have question, what they ask in the question, that the sequence an is convergent, correct? No, it is not convergent actually. Oh, these are the 4 different options, right? You have to choose what is true or false, right?
Yes,
Something
ma'am.
like
These
that.
are 4 different.
Yeah. So there exists two convergent sequence A and Bn which converges to two different non-zero real numbers, but An plus Bn converges to 0. This statement is true, obviously, right? Simply take An to be 1 to the power n. Then what is your sequence An look like? So your sequence An look like 1, 1, 1 and so on, right? And choose Bn to be -1 itself, the constant sequence, not need to be put to the power n also. So your Bn look like -1, -1, -1 and so on. And if you find out what is your an plus bn, so your an plus bn will look like an plus bn, right? So which is again -1 plus 1, 0. So 0, 0, 0, 0, 0 and so on. So here your sequence an converges to 1, bn converges to -1, but your an plus bn converges to 0, right? So this you already observe, I guess.
Actually, I took both of the sequence as constant. One I took 2 and one I took -2. Is it right?
Yeah, that's also fine. There's no restriction.
That's the doubt I have. And the second, in the option 2, the sequence an when n is odd. So when n is odd, it is when we will increase the n, it will converges to 0.
Yeah.
But when it is even, it is already 1. So it is not.
Yeah, the second option is not true, because as if you take n to be even and as you go to infinity, one part of the sequence is going to 0 and other part of the sequence is going to 1. So that means we are not able to go closer and closer to one single point, right?
Okay,
so that's also happening here.
to have the convergent, the both paths should we go to the single point.
Yeah. We should go from both of the paths to a single point. This is not happening here, right? We from the one part we are going to 0 and from the other part we are going to 1. So that means this is not convergent. So this option is not true. Okay. Now the
Then
third.
Option 4 is, I got that, it is easy. But the option third is
correct.
I have doubt.
Which is not increasing cannot have an increasing.
Can you give an example?
So this is also true, because what they are saying that this is a statement that if a sequence an is not increasing, then it cannot have increasing subsequence, right? This is false actually. Simply you can take an to be 1 minus 1, 2 minus 2, 3 minus 3, 4 minus 4, and so on, and make the subsequence of an. I'm denoting bn. This is subsequence. For subsequence, what we have to choose? We just have to select random numbers from the sequence, right? The two conditions are we cannot move backward and we cannot repeat it, right? So here if I'll choose 1, then I'll choose 2, then I'll choose 3, I'll choose 4, and similarly. So here your sequence, this sequence is increasing, decreasing, or neither of them?
Neither of them.
Yeah, correct. Because 1, then we are going to minus 1, then we are decreasing, then minus 1 to 2, again we are increasing. So that means this sequence is neither, right? But this subsequence, this is subsequence of n. You agree on that, right? Correct?
Ma'am, but here
Yes,
is
ma'am.
the if an is not increasing, it means that it is not telling neither. I mean, it can be decreasing.
Yeah, this an is not increasing at all. I mean, I'm choosing in this way now. I mean, first I'm choosing plus 1, minus 1, then plus 2, then minus 2. So it is neither increasing nor decreasing, correct?
Okay.
For increasing sequence, how it look like? For increasing sequence, your an should strictly less than or equal to an plus 1. Here it is not happening at any stage. And this should happen for all n belongs to natural number, not for a single 1 or 2.
If we take an as decreasing, then
no, if an is okay. So now I get your doubt. But this statement is false. You got right. This is a counter example. We get a sequence which is neither increasing nor decreasing, but it has a subsequence which is increasing. This subsequence is increasing, correct? Because for every n, an is less than equal to an plus 1, since n is less than equal to n plus 1. Because this bn is nothing but n, correct?
Yeah.
Everyone is fine with this question? Any doubt? You can ask.
So, ma'am, bn is increasing, but n is not.
Yeah, so that means bn is a subsequence of an which is increasing, but an is neither increasing nor decreasing. So that means it is possible to have a increasing or decreasing subsequence in any non-increasing, non-decreasing non-increasing, non-decreasing sequence, right? Because subsequence is nothing, you just have to pick some numbers from your sequence in that fashion that you should go forward, won't come backward, and don't select index twice. Don't select any an twice, right?
Yeah.
Okay.
Can you explain option 1, ma'am? Once again, can you just call up a little?
Okay, option 1. Let me give okay, fine. I'll just write down one fact that for subsequence you write down these 3 facts. Okay, first one is that if your an converges to a, then any subsequence of an converges to a. This is the one point. Second point, if your sequence an is increasing, then any subsequence of an will also increase. So an also increases. And third point, similar for the decreasing one, that if your sequence an is decreasing, then any subsequence of an also decreases. So these are the 3 facts for subsequence. I don't think you need more than that. And the definition of subsequence. These are clear now. Any doubt on these 3 statements? When the nature of okay, yeah, the nature of subsequence somehow depend on the sequence, but not entirely. For example, here we have an neither increasing, decreasing, but we can get a subsequence which is increasing, right? Okay. Now we go for the option number 1. Is it? Yeah, that there exists two convergent sequence a and bn which converges to two different non-zero real number, but an plus bn converges to 0. So for that I have given example. For an you will take this sequence 1 1 1. For bn you will take -1 -1. I mean constant sequence. Then you know an converges to 1, bn converges to -1. So these are two non-zero elements, right? And they are converging to a different limit, correct? Right? Just constant sequence.
Okay. Okay.
Yeah, and an plus bn is 0 0. So it will converges to 0. Yeah. Fine. So this is the sequence and the subsequence criteria. Now we will go to limit. Okay. So limit. So in the limit, the basic definition of limit, you know, if limit h goes to, I mean, that if right hand limit is same as left hand limit at any point x is equals to a for a function f of x, then we say that limit x goes to a of f of x will exist. This is a basic definition of limit. You have already known, right? Okay. From this, one fact I have to mention, that limit x goes to a f of x will not depend on what is the value of function at that point. If you want to find the limit of function at some point, you're never able to talk about what is the limit of, what is the value of function at that point. Okay. In some special cases, they are equal to f of a, but in some cases, they won't be equal. For example, I will just ask you this simple question. Now, this is for those people who want to do questions, okay? Suppose this is -5 and x is equals to 5. Suppose this is the graph of function. This type of question you have already done, I guess, but this is 0. Suppose 7.
Asymptotic
Yes.
is on
Yes.
-5 or 5.
Yeah. This is y is -5 and it's equal to -6. Now it is correct, right? X is equals to -5. Yeah. So if I'll ask what is the limit x goes to -5 of fx, what will be your answer? Just trace the graph from the right hand side and from the left hand side and find out where you are reaching. If you are reaching at the two different points, then the limit won't exist. If you are reaching to single point, then the limit will exist, and that single point is the value of limit. It's a basic.
Won't exist now.
Yeah, it won't exist, right? Because if you approach from right hand side, what will happen? If you approach from right hand side, we will go to -infinity side, right? So that means the right hand limit is apparently -infinity. And if you approach it from the left, this is the left hand side. Okay. So if you approach from the left hand side, you will go to -infinity. And if you approach from right hand side, what you will go to -5. So that means right hand limit is -5. So both are not equal. So that means limit won't exist. Correct. Okay. What about 0?
Ma'am, you go to 0, right? Not -5.
X goes to -5.
X
Oh
goes
yeah.
to -5, but y goes to 0.
Correct. We are going here, right? Go to 0, not -5. Wait a minute. Yeah, y value has 0, correct. Now what about when okay, this is a case. This is clear to everyone? Any doubt? Now this is some question which maybe Vishal sir, if he will take, he will discuss. So that's why I'm saying. This is clear, right?
Yeah, ma'am.
Now what do you think about limit x goes to 0 of f of x?
Does not exist.
Won't exist.
Wait, I'll put initials.
Yeah, same. Doesn't
Won't exist, ma'am.
Yeah, similarly won't exist, right? Because if you approach from the left hand side, you will go to 3. So in this case, your left hand limit is 3. And if you approach from the right hand side, you observe that the function is not even defined here. It is equal to 3, right? But as we approaches from the right hand side, we will go more closer and closer to 5, not to 3, right?
Yeah.
So that's why
Yeah.
the right hand limit will be 5, not 3. Now some people will get confused. Okay, fine. So as we approaches from the right hand side, the function is equal to 3, but that's not important here. What is important that as we approaches from the right hand side, we will go more closer and closer to 5, not to 3. So that's why the right hand limit is equals to 5. So that's why there's limit x goes to 0, fx won't exist. So it's also not exist, does not exist. Okay, correct, right? Any doubt?
Yeah, ma'am.
So this type of question you are able to solve now. Correct? Okay.
Yeah, ma'am.
So this is one thing I'm discussing to talk you. Okay, suppose in the similar question I will ask, what is the limit? Okay, fine. If I'll ask that does function is continuous at x is equals to 0, what will be your answer?
No, ma'am.
No, ma'am.
Everyone is fine with it, right? I mean, you guys are not speaking, but fine. So yeah.
At -5 also it doesn't exist.
Yeah, because the limit is not existing for continuity. What we want limit x goes to a f of x. First it will exist and it will equals to f of a. Then we can talk about continuity. Continuity is some bigger property than limit, right? So here limit is not existing, so there is no chance of continuity. Okay. So this is one thing. Now, you guys are familiar with drawing the graph. If I'll give you, if in place of this graph, if there is some critical expression is given, you are able to draw it and then you can able to find it, right? You can able to discuss the limit. Correct?
Yeah, ma'am.
Yes.
Yeah.
Can we work out an example?
Ma'am, one doubt here.
Yes. Yes.
Ma'am, is that both the statements same if I say the limit is undefined and the limit does not exist? Is the both
Yeah,
statements
both things are same. That limit is undefined, limit does not exist. For our purpose, both things are same. In general, when limit goes to infinity, some people will say that limit, undefined. But for our sake, we just say that, okay, limit is infinity itself. We won't bother about that much. Okay. So for our purpose, limit does not exist or limit won't defined, or both are the phases are same. Okay. Don't get confused there. Okay. Fine.
Yeah, ma'am.
Yeah.
Take the example of 1 upon mod x.
Okay. 1 upon mod x. Okay. Whenever you got the mod function, just try to apply the property, the definition of limit properly. 1 upon mod a will look like, and it will look like something like
the down graph would just convert it to the upper one.
Yeah, correct. So you want to find limit x goes to 0 of 1 upon mod a, right? Mod x.
Yes.
What it will be.
Yes.
So
so the
whenever you
left
got
hand
the
limit
mod
will
function,
also goes to infinity.
Yeah, so right hand limit will be x goes to 0. 1 by minus x. So this again goes to, no, 1 by minus x goes to minus infinity, no? It won't go to plus infinity. Right hand limit is limit x goes to 0, because in the right side of in the left side of 0, the mod x will behave like minus 1 by x, correct? Right?
Yes.
So that's why we
Right.
have to take 1 by minus x. So it will go to minus infinity. And x goes to 0, it is 1 by x, and it will go to plus infinity. So here also intuitively the limit are not same, so the limit won't exist.
No, the left hand limit also be infinity, because
Why is this so?
ma'am, just plot the 1 upon mod x. It is
1
just
upon
symmetric about the y-axis, and both is
So this is 1
in
by x graph,
first and second order.
and this, no, minus 1 by x will look like this, no? I mean minus 1 by x you are taking. Oh wait, yeah, correct. This is something, I don't know what's happening here. So
Yes,
you have
ma'am.
to take
Both the
limit
limits
x
goes to infinity.
yeah, no, I got it. F of x plus h, x minus h. This is mod of x minus h.
Here, both the limits are
Oh,
equal, so
wait.
we
Yeah,
can
yeah,
say exist,
yeah.
but
Correct. Sorry.
undefined.
So it is plus infinity, but the limit is undefined in this case. I mean, it's going to infinity. So we can say that this limit is equals to infinity or undefined, whatever we can say. Okay, fine. Because we are approaching from 0 minus, so we'll take negative of x. So that means it is minus 1 we'll take, or minus 3, or minus 1 by 3 we'll take, then we'll take minus 1 by 4.
Yes.
Yeah, so that's why we approaching
Then
towards
would
from
become
minus. So
plus.
then minus will become plus, so it will go to plus infinity. Correct. My bad. Okay, sorry for that.
Yes.
Clear? So whenever you have mod, just try to interpret it correctly, because mod will give some problem. Okay. So this type of limit questions are fine now, or we will discuss some other. I mean, I'll give you some question with the expression, so it will be helpful now. Okay, so suppose f of x is defined to be just give me 1 minute, I'll
Ma'am, for the previous question,
yes.
if it is asked whether it is continuous, what is the answer?
For this thing,
Yeah.
actually it is continuous, because but in some another sense, because what will happen that you won't break continuity anywhere. I mean, if you observe the graph, this is a graph of 1 by mod x, right? This whole thing and this whole thing. So at any point you are not breaking the continuity. There is no certain jumps or nothing else.
Oh,
So
okay.
it is continuous.
Because there is no vertical
Yeah.
asymptote?
Yeah, correct. No, vertical asymptote is something else. I mean, the graph is moving so smoothly, right? There is no jump. I mean, discontinuity, what do you mean? Discontinuity means?
But at 0, what is happening at 0? It is again going to infinity.
Actually at x0, function won't define itself. It goes to infinity, but we don't know where it is going. So at x0, the function not even defined. I mean, 0 point will remove from the, okay, 0 will not be included in the domain of function. That is my point.
So for this function, it's defined because of this. We are excluding 0 from the domain itself.
Yeah. Okay. Because this function does not contain, the domain of this function is simply r minus 0. So even though we cannot talk about continuity at those functions where the function is not itself defined, because then we have to define limit x goes to 0, f of 0, right?
Yeah.
For continuity, we want function to be defined at that point. So then it is continuous at every other point, but the continuity is not defined at 0 itself, because the function itself is not defined. So that's why. Okay, so on quiz 2, you should focus on 5 to 8, but you also should revise the basic concepts from week 1 to 4. I mean, basic definitions of relations, functions, polynomial functions, zeros of polynomial functions, multiplicities, degrees, and all. Don't leave those concepts because you will need them. So just don't focus on 5 to 8. I'll say just take a quick recap of from 1 to 4 and then you study for 5 to 8 also. Okay. Apparently, there are more questions, but there are also questions from week 1 to 4. So don't leave that portion also. That's what I'm saying. Okay. Suppose e to the power minus x is defined when 0 is less than equal to x minus infinity is strictly less than x is less than 0. At 0, it is 5. X is equals to 5. And then it is log base 10 of minus.
Ma'am, x is equal to 0, no?
Oh, sorry, yeah. Just remembering what is x is strictly greater than 0. Okay. So then it won't be defined. Wait. To do in place of this is minus 10 and this is plus x. Okay, so suppose this is some sort of function is given to you, and if I'll say what are the points where f is discontinuous.
Ma'am, log to the base minus 10. I mean,
just for base minus a. I mean, minus a is also not defined now. Okay, 1 by 10.
yes.
0 to 1.
Yeah.
Ma'am, one small question in the last example, that is 1 by mod x. If we
Yes.
have a graph, a simple curve, but at one point it's hollow, means it's not defined at a particular point.
Yeah, it is not even defined at that point. It is defined everywhere in neighborhood of that point, but you are not able to find what is the value of f of 0. So that's why we cannot talk about continuity of function at 0.
Ma'am, an alternate example I'm going to take in the same example for any smooth curve.
Okay.
There is a smooth curve in like xy plane, but on one point it's hollow, means that we are drawing a hollow point.
Yeah, suppose this point is hollow, and then
Yeah, now it's continuing from that same point.
And it is continuous from that same point. So continuity won't be defined on that point itself. The limit will define at that point, but you cannot talk about continuity of that point where the function is not defined, where the points are not in the domain of function.
So this function is, we will treat this function as a continuous.
No, this function is continuous everywhere except minus 2. But if I define the function at minus 2 to be this point, then it is not continuous at minus 2. Suppose this is my 1.
No, okay, it's not continuous, but if I am not defining itself, what's the function?
If you won't define itself, then it is continuous except, then it is continuous everywhere. You can say that.
Okay.
Yeah. Because we say the function is continuous everywhere, that means it is continuous at every point of the domain. I mean, they should mention that what type of continuity they are asking. They are asking at a particular point, they are asking on the entire domain, or they are asking on the entire real line. Okay. So if they say that find out the points where the function is not continuous, I mean this type of question won't even define it here, because there are so many ambiguities. Continuity not even defined at -2. So how can we ask continuity on -2? Okay.
Ma'am, in the third section, log to the base 1/10, is this minus x?
No, it is plus x. And erase it. What I was saying, what is my purpose for defining this question is that if you get any complicated example, don't get freak out. Just try to make a graph and then decide what are the functions of, what are the points where the function is continuous, discontinuous, limit exists, won't exist, increasing, decreasing, all those kind of stuff. Just don't be freak out just seeing the expression that, oh, this is so big, okay?
Or we can continue with solving those also. Can we do it?
Which question? Sorry?
Like without plotting the graph, can we do it by
Yeah,
normally?
you can do. If you are comfortable, that is also fine. You can easily do.
Okay.
First try. If not, then I mean this question I think easy. It is so easy. I mean you can easily check it. What are the points of discontinuity?
Yeah. This one.
Yeah. Just tell me itself. In the chat
I'm
box,
not
you guys
getting
can.
how to do this?
I mean, you observe that in this domain of function from -infinity to 0, it is just e to the power -x, correct? Right?
Right.
So that means when your x belongs to -infinity to 0, it is simply e to the power -x. So that means it is already continuous at every point. -infinity to 0, right? So here you don't need to check the continuity. Now, again, when your x is strictly greater than 0, it is simply log of 1 base 10 of x. And you know that this function is also continuous at every point. So that means this function is also continuous for x is strictly greater than 0. Then the remaining point is what? X is equals to 0. So you just bother about x. What happened when your x is equals to 0? So when x is equals to 0, the function value is 5, right?
5.
Correct?
Yeah.
Right.
What is the left hand limit? Now you will left hand limit compute it from this guy, e to the power -x.
Right.
That would be 1.
Yeah, because e to the power -x, as we go to 0, e to the power -x will go to e to the power 0, which is 1, correct? So the left hand limit is 1. And what is the right hand limit? Now you will calculate right hand limit using this guy. This log 1 by 10x, log 1 by 10 of x. Now what will be your right hand limit?
Undefined.
Undefined, correct? Because the graph look like something like this, -infinity.
Yes.
Yeah. So it will something like plus infinity. So that means at x is equals to 0. Yes.
I'm not getting that. How did you get to that graph?
Because as x is strictly greater than 0, your function is just defined by a log, correct? As x strictly greater than 0.
Right.
Yeah, wait. So I'll draw the graph of this function. We are distributed in the 3 part. One is x is equals to 0. One is when x is here strictly less than 0, and one is when x is here strictly greater than 0. In this part, our function is defined by e to the power -x. And we know that e to the power -x graph look like this, correct? Now we'll stop here.
And e to the power of x graph, how does that look?
E to the power -x. E to the power x graph look like something like this, no?
Okay.
That's mirror of it.
Yeah. So at 0, we have a hollow point. At 0, we are defined to be, this is 1, right? At 0, we are defined the graph to be 5. And from as x is strictly greater than 0, we are saying that it is log. And we know that when our base is, this base is a is 1 by 10. So that means it is less than 1. So when our base is less than 1, our graph is the graph of log is decreasing and intercept at 1, 0. Correct? This is the graph of log base 1 by 10 of x. Right?
Yes. Okay,
Yeah.
got it.
So now you got it, right? So that's why I'm saying, some cases it is easy to evaluate the limit using the expression. In some cases you need the graph. So in exam you got more time. So just think about both of the cases where you have to apply any of them. And mainly, first try to cancel out those points where you know the function is already continuous. In this example, we know that when our x belongs to minus infinity to 0, our function is just exponential, right? So it is even though continuous. Don't worry about that, right? Again, when x is strictly greater than 0, it is log, and we know that log is also continuous. Simply at x is equals to 0, there is some misconception. So just try to find out what is happening on x is equals to 0. So that means what is happening on the breaking points. Okay, now, okay, we can do in this way that we'll solve question. Yeah, base 1 by 10 means base a is less than 1. And for less than 1, we have graph of log. Yes? Say something.
Ma'am,
Yes?
ma'am, I have a doubt in one question I have sent in the chat box,
Okay.
which is related to the limit, ma'am.
Related to the limit. Yeah, this an.
Yes, ma'am. An says that an.
Yeah,
Ma'am,
okay,
how can I find the limit?
Yeah, I'll discuss this question. Okay, it's a nice question. So these type of questions is only you're facing in the exam. Don't worry about that. Something unusual will come. Simply basic limit, continuity, differentiability, and you have some questions. You have some topics: polynomials, relations, function, one function, onto function, even function, odd function. Those topics are major topics for the exam. Okay, so don't worry about it. Basically, it's less than 1. Yeah, correct. A could
Excuse
be
me, ma'am.
anything. Yes.
Hello, ma'am. Yeah, I have a doubt that how can we find if the function is bounded or not?
Oh, that's a major task actually. In some sense, you can find easily. For example, if I'll say, if you have fx is minus of e to the power x, then what is the graph of this function? This type, right? Sorry.
Yes.
Something like this. So you observe that it is not going up from the 0. So it is bounded above by
minus
0.
infinity to 0.
But it is going to minus infinity, so it is not bound. Boundedness is it's lengthy topic, so I don't think you guys have gone through boundedness.
So actually, for simple functions, it is I can find even using graph, but
yeah,
there is a
using
question.
graph you can find.
But there is a question. Let me share that.
Just pose the question. Till then, I will.
Okay, so the question is that there is a function.
Okay.
Fx 1 to the power x square plus 2. How to do that?
1 to
X
the
square
power.
plus. No, 1 by x square plus 2.
1 by x square plus 2. Okay.
Yeah.
So this, okay. So fine. Now I got it. What do you mean? Okay. So suppose this is your function and they ask that it is bounded or not, right?
Yeah.
So just compute limit. Okay. Limit x goes to plus infinity. What is it? And limit x goes to minus infinity. F of x. So what is the answer? Limit x goes to plus infinity.
1 by infinity. So
0.
0.
Minus infinity.
1 by infinity.
Again 0, right?
Yes.
So that means as you approaches to plus infinity, the function will not go above by 0. And as you go to minus infinity, again the function will not go below by 0. So in this case, we say that a function fx is bounded. So this is a nice thing. I'll just write it down. Suppose f is a function and limit x goes to plus infinity, f of x is some constant c which is strictly less than plus infinity. It is not plus infinity, okay? And limit x goes to minus infinity, f of x is some d which is again strictly less than minus infinity. In this case, we say f is bounded. BDD means bounded between c, between d and c. This is a main fact. I mean, so it is related to limit, so it can be asked, correct? So for boundedness of function, you just have to compute what is the limit of function near in plus infinity and what will happen to the function when we go to minus infinity. If it comes to some constant number c or d, then you say that the function is bounded. Otherwise, it is not. Okay. So
Okay,
suppose from here we say that if it is plus infinity, then we say that the function f is bounded above.
yes.
And minus infinity, we say that f is bounded below. And together we say that function is bounded between b and c. Okay. Correct. Okay, maybe
Ma'am, so here we got C, D both 0.
Yeah, okay. Sorry, what?
Here we got in the example above, we
Yeah,
got
yeah, CD
C
equals
and
to
D.
0. That is possible. That C and D could be 0. There's
Okay.
no harm over
And C and D cannot, there is no need to C and D equal.
No. There is no need. You just want it. It should not equals to plus infinity or minus infinity. It should not equals to some plus infinity minus. I mean, it should get to some finite number. That is my purpose.
Okay, but if we have to say that, then we will have to say below first and then the upper, I mean above.
Yeah, I mean both things should happen. As x goes to plus infinity, also we want a constant. X goes to minus infinity, also we want a constant. They have given separate name for this limit. I mean, if this limit is constant, then I mean the above limit is constant, then we say it is bounded above. The below limit is constant, then we say they're bounded below. And together, if it is bounded above plus bounded below, then we say the function is bounded. Yeah.
No, I'm asking that when we
Yes.
find range, we
Yeah,
go from we go from below to the above, right?
Below to the who means?
I mean minimum y value to the maximum y value.
Okay.
So here we have two things, minimum and the maximum. I mean, one point is below and the one point is above.
Yeah.
So like the range we write from minimum point to maximum point. Here we have to say from below to the above.
Yeah, but you cannot interpret in terms of range, because in range what will happen, the function should take those values. When there may exist some point between d and c or c and d where the function won't take the value. So
okay.
Yeah, got it? Got my point?
Yeah. Yes, ma'am.
Okay, so now this question we will first discuss. What is it? Yeah, we all will speed it up. Don't worry. En is given by yeah, we will schedule one more session. Don't worry about that. And first focus on this session. If we need, we can schedule. But you guys should practice now. I mean, 10n plus 1 plus 7n by n. Yes, this is amazing. This is a question, right? In the chat box. You guys want to discuss
Yes,
it?
ma'am. Yes, ma'am.
Okay. So what we have to do in this question? Convergence, right?
Yes, ma'am. Find the limit of this.
So what do you guys think? What should we do? I mean, you guys attended this, so you think about something, huh? That okay, fine. I'll
L'Hopital
do
rule
this.
because
Sorry, what?
Ma'am, we can separate the numerator.
We
For
can.
each element, sin
Yeah.
n by n and cos n by n will get.
Okay. But that won't give me something else. Okay, fine. So what happened? In general, suppose in general, if you have some sequence, let's suppose Bn, and it is defined by some two sequences, Cn and Dn, where Cn is defined when your n is odd, and Dn is defined when n is even. Okay. And if your Cn goes to some C, and if your Dn goes to some D, and your C and D are same, then your Bn will also goes to that C is equals to D, whatever quantity will take. This is a fact by using the subsequence property. I mean, you guys might not know this, but this is one thing. If you have sequence which is defined in this way, that odd is somewhere and even is somewhere, so in that case, just take the limit of first sequence Cn. What is it? Just try to find out what is the limit of Cn, and then try to find out what is the limit of Dn, and then try to say that okay, if C and D are equal, then your sequence Bn will also converge to the same point. You got this fact?
Yes, ma'am.
Any doubt on this?
yes, ma'am.
Sorry, you are not audible. Actually, this
No,
is
ma'am.
something. Yeah, this will come from.
No, ma'am. I have no.
Yeah. Okay, fine. So we have to solve this thing. That what is the limit of this function? So now just try to evaluate in the some sense. I mean, same sense. This is your Cn. So what is limit and tending to infinity of Cn? What is it?
The 10.
Yeah. Limit and tending to infinity of Cn is n. Because this is 10 plus 1 by n plus sine n
1.
by n. Right?
Yeah,
We
10.
get 11.
Goes to 0. This goes to 1, right?
No,
So
ma'am.
limit will
11.
be
This sine n by n also goes to 0.
No, it goes
n
to
n
1.
by n goes to 0 or goes to infinity. Decide. I don't know actually.
Yes, ma'am. Because
0.
as we
As
send
n goes
n
to
to infinity,
infinity,
sin n
sine
is the
n
bounded.
actually sine n is bounded by 1 by n and minus 1 by. So by sandwich theorem, this goes to 0, this goes to 0. So sine n by n should goes to 0 as n goes to infinity.
Yes.
So
yes,
yeah, that's
yes.
correct. So it is 10. Fine. Now what is the limit n goes to infinity of dn? And this is your dn. So same thing you can apply. Limit n goes to infinity. This is 10 minus 1 by n and plus cos n by n. Again, cos n by n is bounded by 1 by n and minus 1 by n. So that's why it also goes to 0. This also goes to 0. So that means this is also equals to 10. So that means your D and C will converge to same thing. So that means your an is also convergent. Also convergent. And where it converges, it also converges to 10. Got it? So answer is correct? I think so. It's correct.
Yes, yes.
Yeah.
It is given 10.
Fine. Sorry, you are not audible correctly. You can message.
Yes, ma'am. It is correct.
Fine.
Oh, ma'am, I have doubt in this. You did sandwich principle.
Oh, you have doubt in sandwich principle?
Yeah, so sin n should be between -1 and 1.
Yeah, it is bounded by minus 1 by n and plus 1 by n. So n minus 1 by n as
why we
n
are
goes to infinity
taking
will go.
1 by n? Okay, because there is one sin n
There
by n.
is
Okay,
n.
yeah.
Yeah.
Take.
Fine. Because simply you know that -1 is less than equal to sin n is less than equal to 1, right?
Yes, yes.
So
We
by
are,
n
we are taking
also
one by
will
n, yeah.
give the same thing. Yeah. So this is basic Sandwich theorem.
Ma'am,
Yes.
I have a doubt in one PYQ which is related to the composite function. So can I ask?
Yeah.
Ma'am, I have posted that question in the chat box. I have
This
solved, but
what is this? F of x is equal e to the power a, this question, x square minus 7x plus 6. This is your question, right? Hello?
no, ma'am. F of x equals to log 2. Yes, ma'am, I'm audible.
Yeah. Where it
Yes, ma'am.
is?
F of x equals to log 2 base 3x.
Check the latest question.
F of
Latest
x
message.
is equal to log
base 2
base 2
in the bracket log base 3x.
this basis this one base.
No, ma'am. Ma'am, there is one log extra. Log base 2 in the bracket, then log base 3, then a bracket open and close.
Okay, you send in chat box
This is
again.
not.
I mean, it is not that much clear.
Okay.
Just
Ma'am,
send
I
it.
can repeat.
Okay, fine. Repeat.
So log to the base 2
Okay.
bracket log to the base 3 of x.
This one.
Yes, this is fx.
This is
and
fx.
there is another one called gx.
Okay.
Which is minus x square plus 4x plus 77.
Okay. What do you want? You want
And hx is f of gx. Yeah, right.
F composite.
F of g
you
is
want the domain of F composite G or something else? Domain, right?
Ma'am, it asks for the maximum value of gx and the maximum value of hx.
Okay. So this is question in quiz 2 exam because maximum and minimum are going to discuss on the week 9 part.
Yes, ma'am.
Okay.
It's from quiz 2.
Fine, don't worry. So log base 2, log base 3.
Let me check, ma'am.
Yeah, because
I think this is from n term. Maybe.
Yeah, this should not be in here because you haven't studied what is maximum minimum till. I don't think it is a question. Okay.
Ma'am,
So
I have one request.
Yeah.
In the calendar, we don't have any math session after today, before the quiz one, and it's could you schedule a session on the Saturday for the doubt clearing or some specific because we have a mock also for the
Yeah.
mock discussion and all.
After mock, you want a doubt clearing session or before mock?
Yeah, ma'am. After mock, it will be better that if it's scheduled on Saturday.
On Saturday. When is your quiz?
From Sunday.
Okay, so you want a session on Saturday? I mean,
Ma'am, it's okay if it's tomorrow or means it's just 2 days, Friday or Saturday. Till Saturday, it's endpoint thing that if any doubt is there, it will be better.
okay.
Ma'am, can we extend this session?
Yeah, we can extend this session. There is no worry about that. Okay, we can go up to 11, maybe.
Okay,
Or
ma'am.
if you need it, we can go up to 12.
Okay, ma'am. No
or
problem.
11:30. Yeah.
Okay. So, can you just go through the PYQ questions?
Yeah, PYQ questions about.
Excuse me, ma'am.
Yes.
Ma'am, I have checked. This question is from September term 2023. Quiz 2.
Quiz 2. Well, I think they might have discussed at that term, but this maximum minimum question won't be appear in your quiz paper, okay? Because we haven't discussed what is maximum, what is minimum, and all.
Ma'am, but g of x is a parabola, no? So we can find the maximum, right?
G of x, yeah, correct. But what about f composite g? I mean, it is defined by the log of something, right? And the log base, then it will go because this is polynomial, right? So this polynomial will have range, the whole real number, right?
No, again, it's a parabola, right?
The
So
thing is,
Yeah, again, it's parabola.
GX has certain point that is at vertex, it will have some maximum value. But what log of this f of x is, an increasing rate. This is it's
Okay. So log is
increasing in
increasing,
nature.
decreasing function. You can use
Yeah,
that. Okay.
it's increasing nature. So just we have to plug the maximum value and they calculate.
Maximum of the polynomial that you guys are saying, right?
Yes.
Okay. Now I got it. But it also should not be there. I mean, maximum, minimum. Oh, fine. I mean, this is clear, but this is log base 2, log base 3 of minus f square plus 4x plus 77. So this maximum point is at x is equals to minus 4 by minus 2. That means at x is equals to 2, this function will have maximum point, right? This is downward parabola, no? Right?
Right, yes, ma'am.
So the maximum value is just this log base 2, log base 3 of 2. That you guys are saying, and I think that's also correct because log is ultimately an increasing function. So if we take some minimum, I mean not 2, the f of 2.
Yeah, it's f of 2.
But we just want point where it is maximum.
Okay, ma'am, I got it, ma'am.
Okay.
Thank
Now, just give me 1 minute. If there is some session, PYQ session on tomorrow or something else, I'll just discuss and then just give me 5 minutes, okay? Till then, you will do this question.
Okay.
If fx is under the root of x and gx is x cube minus 27. Okay. Same question. Then what is the domain of f composite G? It's an easy question on the base of domain of f composite G. Just write it down. Yeah, just post it out. We'll discuss. Everyone got the solution? Shall we discuss? I wait for some time.
Can we go ahead and solve this one?
Yeah. Okay, so what is the domain of Gx?
R, ma'am.
The whole real line, correct? Now, our fx is given to be under the root of x, right? So for defining fx, we want x to be greater than or equal to 0, right?
Right.
What we want our gx to be greater than equal to 0. So that means we want our x cube minus 8 to be greater than equal to 0.
Right.
Right. So that means our x cube should greater than equal to 8.
Right.
Now, what are those x where our x cube is greater than equal to 8? I mean,
2, ma'am.
yeah. X should lie between -2 to 2. I mean, x should
be greater than or equals to 2.
Yeah, correct. Because minus sign will again get -8, minus something, -8 will again later. So that means x should be greater than equal to 2, right? Okay. So this is the domain of F composite G, correct? Simply 2 to infinity. So these type of questions only you will get to see. I mean, first hot topic for the exam is the domain of G composite F, or domain of composition function.
Ma'am, if it would have been x squared minus 4, for instance, then what?
X square minus 4, then you will have two different things. That means your x square minus 4 should greater than equal to 0. So we can distribute into two parts, that x minus 4 into x plus 4, correct? This should be greater than equal to 0. Now again we can use
X
the Wavy.
minus 2 and x plus 2.
Yeah. Sorry.
Okay. Okay.
So this is -2, this is +2. Again we have plus sign. So plus, minus, plus. This is our restricted domain. So that means our x belongs to close interval -2 to 2. This will be the yeah.
How did you do that without putting values? I mean,
Yeah, this is known as Wavy curve method. I mean, if you have something like suppose x minus a1, x minus a2, and so on, x minus an, and this is greater than equal to, suppose you have to find out all those values of x such that for this expression is greater than equal to 0. So what you will do, you will plot those points according to the real number, real line. I mean, whatever the preceding and I mean in the order. So suppose this is the natural order. And if there is positive sign here, you will start with positive here, positive, negative, and alternately put the positive, negative sign. And if you want greater than equal to 0, the shaded portion of positive
will be included.
This will be negative, this will be positive, this will be negative. Okay. So the shaded portion of positive will give the required answer. This is known as Wavy curve method. Similarly, if you have minus sign here, and again you want to get greater than equal to 0, then you will start by negative sign.
Negative.
That negative, positive, whatever it is. And suppose this is positive, then again negative, positive, negative. And then shade the positive sign. That will gives you the required answer. For greater than equal to 0, shade the positive part. And for less than equal to 0, shade the negative part. And the sign, starting of sign will depend on whatever sign come before the expression. I mean, here we are getting plus sign, so that's why we started with plus. If we get minus sign, then we will start with minus. And we should start from the right hand side.
Okay.
So this is known as basic Wavy curve method. There are some different version of it that will take much time to understand, but this is a basic thing, and that this will used. I mean, this will make your work so less. Otherwise, you have to distribute this thing, right? First, you have to compute whenever this both thing is positive. Then you have to compute whenever both thing is negative, and then we have to take the
I
UVL.
always have to put.
But ma'am, here you have shaded the negative area. Why?
Oh, sorry, not positive area. No, wait. So negative, positive. We want greater than or equal to 0. So we want positive area. So this should not be the case, right? Why we shaded this? I mean, first root will be -2 because this will give x is equals to -2. This will give our x is equals to 2. So the second root will be 2. Here we have positive. So again, positive, negative, and positive. I want greater than or equal to 0. So yeah, this will be the answer. Because if you take, suppose I will take x to be -4. Then -4 -2 and -4 plus 2. So what is this? This is -6 into -2, which again become positive. So sorry, this is not the case. Yeah. So your answer will be open minus infinity to close to and -2 union with close to plus infinity. Yeah, sorry. But you got the point what I want to say, right?
Yes, ma'am. But then sometimes it is not this straightforward, right, ma'am? Wherein we can
Yeah.
just substitute.
Sometimes it is not, but it won't be that much difficult. I mean, you can able to break it down in some factors. I mean, here we easily see that okay, it's just x square minus 4. Maybe there will be some complicated, I mean, some quadratic function that you should again break down into some factors. Suppose x plus alpha, x minus alpha, and then apply the Wavy curve method. This may be possible, right?
Okay.
Okay. So what is the next question we have to discuss? This one, the number of solution of the expression, right? Okay. So this is a question. Okay, so I'll just find the number of solution of some fx is equals to gx. Okay. So if the question is ask you that you have to find the number of solution of this type of expression where your fx is some function and gx is some function, okay? Then what you will do, if you are able to draw the graph of fx, so draw the graph of fx and then again draw the graph of gx and find out what are the numbers of intersection point. That will gives you the number of solution of the expression. Solution of fx is equals to gx. This is the process that if you want to find the number of solution of some expression, suppose this is some e to the power x plus log x is equals to 0. If someone says that find the number of solution of this expression, what we will do, it is look like, okay, it is a little bit tough to solve. But what you will do, you will just take it e to the power x and then it is equals to minus of log of x. So just draw the graph of e to the power x. So the graph of e to the power x will look like this, and minus of log of x will look, I mean, plus of log of x will look like this. So minus of log of x will look like this. So that means it will eventually intersect at least one point. I mean, it will eventually intersect at one point. So that means there is only one solution for this equation. So this is a concept for finding the number of solution using the graph of function. This is clear? Fx is equals to gx case. Yeah, it is not always easy to plot the graph of the left hand side in every expression. But this is one of the way to doing it. That's why I'm saying. Okay. So this is clear, right?
Yes, ma'am.
Yeah. To find the intersection point of both of them, and then you will get the number of solutions. It is not always easy, but in some, yes.
I have posted a question in chat box.
Yeah. Just This is your question. Now, find the solution of x to the power 3 by 4 log base 2 of x square, right? Log base 2 of x minus 5 by 4 is equals to root 2. So we have to find the number of solution. Intuitively, it appeared to be more, I mean, this is not that much trivial that how to go with the solution, because it is neither, yes, is minus 5 by 4 inside the log or outside. It's outside. I mean, it's something quadratic in terms of log base 2 of x. Okay, so we have to find the number of solutions. So first, what we'll do, we'll try to break it down into simpler steps. So I'll apply log base 2 here. Or let's suppose I'll apply log base 2 here. Then what will happen? This whole quantity will jump ahead and we get 3 by 4 log base 2 of x, the whole square, plus log base 2 of x minus 5 by 4. And again, we have log base 2 of x. And this is equals to what will be? It will be solved to log base 2 to the power 1 by 2, right? So 1 by 2 will again jump ahead. So it is 1 by 2. And again, log base 2 of 2 will become 1. So it is just into 1. Okay. Now, in this expression, if I'll suppose that my log base 2 of x is equals to t. Okay. Just substitute in place of log base 2 of x. Let us assume that it is t. Then what will happen? Now, here we are not able to draw the graph of both side of the function. Obviously, this side is just constant function, so you can draw. But x to the power some quadratic function in log, this is not very trivial to draw. So obviously, we are not able to use the graph method here. So we just have to go through some algebraic computation and then try to observe something. Maybe we can get something you want, right? Now it is become easy. Yes, we can draw cubics. Yeah, correct. So now it just become 3 by 4 of t square plus t minus 5 by 4 into t is equals to 1 by 2. Now again, this will become the cubic expression in t. So that means this something 3 by 4 t square plus t minus 5 by 4 times t 2t minus 1 is equals to 0. So this becomes some cubic polynomial in t. So that means intuitively we can go, okay, fine. We may have 3 roots. But this is not the case because we have replaced t by log base 2 of x. And log base 2 of x will have range the whole real number. Yeah, so whatever t we will get, we can find an x such that log base 2 of x is correct. So till now it is clear that we get a cubic polynomial in terms of t, right? Everyone?
Yes, ma'am.
We are solving this question that we have to find the number of solution of this expression. So we try to break it down into simpler steps. So what we'll do, we'll apply log base 2 on the both of the side, because somehow we get sense that, okay, log base 2 of x is there. So maybe we can get something in this way. So just apply log base to both of the side. We reduce into some simpler form. At the end, we get a cubic polynomial in t. Okay. So this is nothing but a cubic polynomial in t. And we know that cubic polynomial in t has 3 roots. 3 roots or 3 zeros. So can we find the roots explicitly? Let's try, okay. So this is 2, I'm multiplying 2 inside. So this will become 3 by 2 of t square plus t by 2. It again get complicated. Okay, 3 by 2 t square plus t by 2 minus 5 by 2, right? Is equals to minus 1 is also there. So we can again have to solve using differentiation. What do you mean by using differentiation?
How is it t by 2?
Oh, sorry, I'm multiplying 2, so 2x, 2t, right? Yeah.
Yeah.
So the second one, minus 1. So actually I have to solve it into cubic, and then I have to find out that the 3 roots are real or not. You know what I mean? I mean, if we get something t is equals to iota, or I mean some complex root, then we cannot find nx for which log base 2 of x will be that thing, right? So we can find minimum maximum value, but that won't help, right? Because t is equals to 1 works. Okay, so let's try. So let us
But what is the question asking, ma'am? We have to find
number of solution of this expression. That
So
x
will it
to the
not,
power.
since it is cubic, then will it not be 3?
Yeah, but you know, there are some cubic polynomials. Suppose x cube minus 1 is equals x cube plus 1 is equals to 0. This cubic polynomial has only one real root, right?
Yes, sir.
So if we get 3 real roots, suppose I'll get 3 real root alpha 1, alpha 2, alpha 3 for this polynomial, then I can easily found an x for which log base 2 of x1 is equals to alpha 1, log base 2 of x2 is equals to alpha 2, and log base 2 of x3 is equals to alpha 3, right? If we get 3 real numbers. This fact is clear because log takes the whole range, right? I mean, the range of logarithm is the whole real number, right? So suppose this is my alpha 1. So for alpha 1, I can get an x1 such that log base 2 of x1 is equals to alpha 1, right? And this x1 will work for me because I'm assuming t is equals to log base 2 of x, right? Are you getting my point?
Yeah.
So here just one concern we have to make, that our all the 3 roots should be real, because if the only concern is that our all 3 roots should be real, because if they will be complex values,
Complex.
then we cannot find such x for which log base 2 of x is equals to that number, right? So the only concern here left is that we should able to get 3 real roots. So they say that by hit and trial we can get t is equals to 1 will work. So let's see t is equals to 1 will work or not. So this is 1, and this will be 3 by 2 plus 2 minus 5 by 2. So what is it? Minus 1 again. Yeah. So LCM will be 3 plus 4 minus 5 by 2. So, and again we have minus 1. One will won't work now. I mean, how it is working? 1 is not working, right? Yeah, 1 is not a solution. T minus 1, t plus 2, 3t plus 1, 3 solution. Good. So someone has calculated that this is the solution, t minus 1, t plus 2, and 3t plus 1. Just calculation, you guys will do it easily. So, okay, so 3 solutions we have. So that means t is equals to 1, t is equals to minus 2, and t is equals to minus 1 by 3. Now, these are 3 real numbers. So for these 3 real numbers, I can find some x1, x2, x3 such that log base 2 of x1 is equals to 1, log base 2 of x2 is equals to minus 2, and log base 2 of minus 1 by 3 is equals to, x3 is equals to minus 1 by 3, right? So that means this expression now has 3 roots, 3 solutions. Now you got it?
Ma'am, can you summarize this after the third step, means after taking log base 2x equals to t?
Yeah. So what we'll do, we somehow get sense that, okay, this is some polynomial in log base 2 of x. Okay. So I substitute log base 2 of x is equals to t. Then I get a cubic polynomial in t. Then I solve it. I mean, someone solve it, and we get this factorization of that cubic polynomial. So for that cubic polynomial, I found out that, okay, these three are my roots of that cubic polynomial, right? This much you understand, right?
Yes, ma'am. Understood.
After that, as we know that log base 2 of x has range the whole real line, right?
Yes,
so that
ma'am.
means for every real number, we can find out an x such that my log base 2 of x is equals to that real number alpha, right?
Right, ma'am.
So corresponding to this t1, I can found an x1 such that log base 2 of x1 is equals to 1, right?
Right, ma'am.
So if I substitute this x1 in this expression, if I substitute this in this expression, suppose I substitute x1, so then what will become log base 2 of x1? This will become 1. And I know that 1 is the solution of that cubic polynomial. So it will again become 0. So that means x1 will satisfy our given expression. Got it?
Yes, ma'am. Got it.
Yeah, correct. Fine. So sometime the finding the number of solution may get little bit tricky, and sometime it may get little bit easy, but you have two methods. First one, I'll suggest apply graph method if applicable. That will help. Okay, so there are two methods for finding number of solutions of any expression. First one is the graphical method, and second one, just do the routine calculation, or try to change the expression into polynomial. That you can see. Try to change your whole expression into some polynomial by replacing some constant, and then again interpret in terms of what you can say, that range of that whatever substitution you have make. For here we have make log base 2 of x is equals to t, and we know that the log has the whole real number as a range, so that will work for us. Okay, so this example is clear, right? Finding the number of solution of any expression.
Yes, ma'am. It's clear.
Yeah, because you may see some questions based on that, so that's why. Okay. Now if some function is given to you, then you can tell that this function is increasing or decreasing, right? By just taking that, let us suppose x is less than y, then your f of x should less than f of y, then you say that the function is increasing, and the vice versa for decreasing, right? E to the power x for all x to real is, yeah, it is always positive. Okay, so we have another question. What is the set of f of x positive for all x? That's a nice question. Okay, let's try to. So your f of x is given to e to the power a of x square minus 7x plus 6. Right? Okay. So then we have to find out yeah. Right.
I think, ma'am, this question is covered by Ashish sir in the yesterday's PYQ
Okay,
session.
it already solved, then that's fine. So we won't do it. But someone has doubt, so I may just clear it.
Okay, ma'am.
A and B, they say that. So positive negative part you can easily compute. I mean, if it is positive for minus 10, it won't go below.
Ma'am.
Yes.
So I have doubt in this, but if the previous session is recorded, I will watch this.
Okay, fine. Got it.
Is it recorded? Who is telling that?
Is it recorded? Tell him.
Yeah, Asit sir, I think take the session PYQ session.
You guys already
tomorrow
have lots of PYQ session, right?
Two PYQ
Two PYQ
taken by Asit.
I mean, tell me the date, please.
Yesterday, I think. Yesterday.
Okay. Okay, ma'am. I will check.
Yeah, sure. Someone again posed this question. You want to discuss it? This question?
Yes, ma'am. Yes, ma'am. The question which is showed, I have a doubt on this question.
Okay. So it already discussed or this topic? This is question from the previous terms. Log base has 5x. And then we have, what is the log base here? 5x to the power 1 by 5? I think so. 5x to the power 1 by 5 is your base. Means 6x cubed.
Yes, ma'am. 1 by 5 is the power.
To the power 1 by 2. That's why you guys are searching. So the question is, your expression is that 5x to the power log of, and here base is 5x to the power 1 by x, 1 by 5, and then we have 6x cubed minus 36x square plus 66x minus 35 to the power 1 by 5 is equals to 1. That's correct? Right? No
Yes.
solution?
Yes, ma'am.
What does it mean? I mean, you have already solved it. This question I haven't discussed yet till now, right? What do you mean? Oh, okay. So you means that okay. Someone just pointed out that this is something a to the power x is equals to 1 type of case, right? This is 5x to the power something is equals to 1 type of case, right? Right?
Yeah.
For this, we want x to be equals to 0. But your log will not be equal to 0. But wait a minute, there is a catch here because you are not given just log base x. I mean, for example, if you have function of log base 2 of 1 plus x, then the graph of this function will look like this thing. As I tell you, shifting of units, right? So we are adding 1 unit here. So we will shift into the left side of the graph 1 unit. So here this function attaining the value 0, right? So you cannot just imply that okay, log base 5 of x is equals to 1 by 5, it won't equal to 0. This is something else. This expression will play a key role here. You got my point? Oh, yeah, correct. So
Yes,
that's why it's not that easy to solve, but let's try. Okay. Again, I get some sense, okay, it's log base 5x to the power 1 by 5. So if we take the base 5x to the power 1 by 5, we may get something. Okay. Let's take log base 5x. Sorry, what?
Yeah, we can take the power 1 by 5 as 5. It is property
yeah, 5.
of the log.
Okay, right.
And that will come out to be 5 by 5 in whole expression, the whole polynomial expression.
Yeah. So that means you are saying that if we take 5x, Now this is 1 by 5 is there. Log base, this 1 by 5 we are taking outside. So it will become log of 5x to the power 1 by 5. And then we have some expression here, then this is equals to 1.
Yes. And also base the power exponent of the 5x 1 by 5. That 1 by 5 also come out to be 5x.
This 1 by 5.
out.
Yeah, it will come by 5 of then, right?
No, ma'am. The base is 5x to the power 1 by 5, right? You can take that out by and say
5
1 by
multiplied.
1 by 5 essentially, right? So this
Yeah,
1 by
yeah,
5, 1 by 5 get cancelled essentially.
yeah,
right?
but this also will give something,
So
right?
all we have that this polynomial as expression equals to
I
1.
mean, just take log base 1 by, I'm just taking this thing that I'm applying both
Yeah.
sides of log base 5x to the
That
power
will
1 by
also.
5. So then this whole thing will jump out. So this will become log of 5x to the power 1 by 5. And then we have expression here, and then this should be equals to, the log 1 will become 0, right? Correct?
Yes, sir.
And the base to the power 1 by 5 will come as 5 here. So this is 5 of 5x of the expression is 6x cube minus 36x square plus 66x minus 35. And now it will equals to 0, right? This is equals to 0, right? Am I right or not? Yeah, correct.
Yeah.
Why 5 log 5x, ma'am?
This base property, I mean log base a to the power n of x. This is same as 1 by n of log base a of x. This is also an property of log. I mean, if you have power
Yes,
of
ma'am.
x,
But we also are bringing out the power of the polynomial, right?
Polynomial, yes.
That 1 by 5 and this 1 by 5 get cancelled.
no, I haven't taken the power of polynomial. I mean, I apply this log base 5x to the power 1 by 5 itself.
Excuse me, ma'am.
Yeah.
Ma'am, I think this question is covered in the week 6 practice assignment, and the solution is given on
Okay,
the
the
portal.
solution is given. But you
Yes.
guys have doubt on this question, so we can solve it. I mean, we reach almost. We just have to find the number of solution of, okay, you have given already the solution. Yeah, so that's why I'm saying. Yeah, we got the correct expression, even though. What is the doubt here?
Ma'am, for applying the formula, I was having doubt. Now it's clear.
Clear, right?
Yes, ma'am.
The other person?
That was my doubt, ma'am.
Okay, fine. So again, we can pull this 5 on that side. So it becomes just log 5x of 6x cube. This thing is equals to 0. And then again, we can apply the e to the power 0 thing. So that means our 6x cube minus, I mean, this thing that we know that log base a of x is equals to y, if and only if a to the power y is equals to x. So that means 5x to the power 0 is equals to this thing, 36x square plus 66x minus 35 is equals to 5x to the power 0, right? So this will imply 6x cube minus 36x square plus 66x minus 35 is equals to 1. And again, we get a cubic polynomial. So the number of solutions are 3 here also, right? Okay. Now fine. Any doubt?
Yes, ma'am, it's fine. No doubts.
To everyone?
Yes, ma'am.
Yes.
You guys are following, right? I mean, if someone has any doubt, just point it out. Fine. So this is one question. Any other question you guys want to ask?
Ma'am, can you take my question?
Yeah, what is your question?
The previous one, which I told to see in the recording, because recording is, I think, not available.
Which one? E to the power?
Yeah, e to the power a.
Just tell me question. E to the power a of some. What is the expression here?
Okay, let me check.
Yeah.
So e to the power a x square minus 7x plus 6.
And what we want? We want to find it as positive in
Positive in
minus 10 to 5, I guess.
open minus 10 to 5.
Yeah.
If a is greater than 0, strictly greater than 0.
If a is strictly greater than 0. So you want to find out some positivity and negativity. So what you can do,
I
first of all,
simplified it.
just
I took the ln.
But why should you have to take the ln? I mean, we can take the ln if we have some LHS is equals to RHS type thing. But
Ma'am, we can say the quadratic function which is written here, if it's positive, then
yeah, correct,
my
because
whole
e to the
function is
power
positive.
x, yeah, e to the power x has this graph, right? So if we have x, no, how can you say that? Because we have e to the power x something, right?
Means, ma'am, if we got that points where this quadratic function is positive and it's already written a is greater than 0.
X minus 1, x minus 6. Yeah, this is the simplest route. You can go in this way also, that a of x minus 1 into e. It's a power of power. So these are the roots, right?
Yes, ma'am.
Acha, now I got it, what you want to say. Okay, fine. E to the power a of x square minus 7x plus 6. So I want when it is greater than or equal to 0. So we can just apply log here. So this will become a of x square minus 7 of x plus log of 0 doesn't define here. So we cannot apply log, okay? Yeah, we cannot apply log. So I want to find it when it is positive in the center. So we can split it out in this way.
Like eliminate the e and it goes to RHS and it become 1. E to the power 0.
E to the power 0. I mean, if
And
I'll apply the...
Okay, we don't
Ma'am,
have.
right.
Oh,
E-
sorry.
Ma'am, e to the
Yes.
power anything will always be positive, no?
That's the thing now. Because
so whatever the value of x is,
you mean this thing, right? This is
Why
also
would
greater than
e to
equal
the
to
power
0.
of anything would be positive? We just saw e to the power of minus x.
that is 1 by e to the power of x, which is again positive, no?
Yes, because we have both the graphs as
range is,
above
yeah.
the x-axis.
We always have this thing to be positive, but no, there may have some shifting, but the shifting should happen in the y. Here the shifting is just happening in the x, so I don't think it will go even below the x-axis or y-axis. I mean, this function is already always positive. You don't think so? Because this is something e to the power of a of x square minus 7x plus 6. So this is same as e to the power a of x minus 1 into x plus 6. Oh, sorry, x minus 6, right? Okay. So just try it out in this way. Fine. So this is my 1 and 6. And again, I have positive, negative, positive. So I know if my x belongs to minus infinity to 1 union with 6 to infinity, then this expression, let us suppose I'll suppose it to be t, then we know that our t is greater than 0, right? This much you guys agree, right? Am I correct?
Yeah.
Yes.
So whenever your x belongs to this interval minus infinity to 1 and 6 to infinity, your t, which is nothing but x minus 1 to x minus 6, this is also some positive real number. And for some positive real number, we know that e to the power t is again greater than 0, right? Because this is some positive real number. So suppose this is something here, right? And we know, suppose this is something alpha. And for we know that for this alpha, our e to the power x will always have positive value. So this again greater than 0. So the half of real line we have done. Now what about x is equals to 1? So when our x is equals to 1, our expression will become 0. So it is e to the power 0, which is 1. This is again positive, right? Similar case with x is equals to 6, right? Correct?
Yeah.
Okay. Now for x between 1 to 6, what will happen? When x between 1 to 6, this expression that x minus 1 into x minus 6, this is some negative number. Suppose this is minus t. And again, we know that e to the power minus t is again a positive number. Even though whatever t will be, that won't affect the positiveness of e. So I think this expression is always positive, no matter whatever thing you will get. It doesn't depend on that.
That is
Yes,
true.
ma'am. Yes, ma'am. Because
Yeah.
E itself is positive.
Yeah, e itself is positive, and there is no scaling in y. If suppose the same graph, okay, suppose the same thing, that e to the power a of x square minus 7x plus 6, same thing.
If
Then if I apply just minus, let's suppose minus 100, then obviously it will go beyond. So then we have some question about negativity of the function. But if it is just e to the power something, that it should always be positive. That's my claim. And
yeah, and if we have e to the power minus t also, then it will become a
it will
fraction,
again become positive.
positive fraction.
Yeah, correct. Fine. Nice question. Nice observation. Any other doubt? Any other question? Any concept you want to recall?
Week
Yes,
7
there
and
is
week
one question.
8 now.
Week 7, week 8. Week 7 is of logarithm and limit and continuity phase.
Okay,
Yeah, this
that
is a nice question. We will do it. Okay, just one question though. E to the power 3x. Okay, what is it? Is equals to 0, right? Find the number of solution.
Ma'am?
Yes.
Ma'am, I have a doubt over that week 7 or 8, that continuity of series or a topic.
Okay. So yeah, we will come to that after this question. Okay, just try to solve it, then we will discuss your doubt. Okay.
Okay.
Yeah. So find out the number of solution of this expression. What do you guys think? How there are two solutions, three solutions. No, don't do that. Like, okay, e to the power x is common, so cancel. That's your answer is correct. Correct. This long break. What is your name? So, but your approach is not correct. That's not always possible that you can common something out and then cancel. Because if you take common e to the power x, still there are e to the power 2x. will remain. It won't become the just polynomial. So try something.
Two solutions.
You cannot take log both sides because on the right hand side we have 0 and you know log of 0 won't define. So also, yeah, correct.
Ma'am, did you change the equation? I thought it was only 3.
No, yeah, this is the only equation I use.
So e to the power of 3x minus 4e to the power of 2x plus
3 to the power x is equals to 0. That's the expression.
Ma'am, can we take e to the power x equals to y? So
think about it. Can you take e to the power x is equals to 1? You know all thing about exponential function. Just put together and find out. There is nothing in this question. And we have already solved some more tough questions in this. Yeah, correct.
can we discuss?
Yeah. Aryan got the solution?
Yes.
Yes, ma'am.
Yes, ma'am.
Enough time. So here you see that, okay, there are so many e to the power x. So I told you just try to convert this into polynomial, right? So just take simply e to the power x to be t, right? This is the most general approach you can see. So our expression will become t cube minus 4t square plus 3t is equals to 0, right? So now this is simply t square minus 4t plus 3 is equals to 0. So this is t minus 1, t minus 3 is equals to 0. Now your work won't stop here, okay? So you get 3 solutions, t is equals to 0, t is equals to 1, and t is equals to 3. Now the question remains that does there exist, this is sign for there exist, does there exist some x1, x2, x3 belongs to real number such that such that e to the power x1 is equals to t1, which is your 0, e to the power x2 is equals to 1, and e to the power x3 is equals to 3. So here the answer is no, right? Because e to the power x1 cannot be equals to 0 for any x belongs to real number, right?
Yes, ma'am.
So for t is equals to 0, we cannot get some x1. Here we can find out because x2 is nothing but 0. If we put x2 is equals to 0, then we can get, okay, this is true. And here also we can find out, yeah, they may exist. Simply take x3 to be ln of 3, right?
ln3, yeah.
That will work. So that means for this t is equals to 0, we cannot find an x such that e to the power x1 is equals to 0. Because we have to find x such that which satisfy this expression, not this polynomial, right? So when we find out the roots of the polynomial, we have to go back to our original expression. Does it possible or not? I mean, even though the roots of polynomial will give the maximum number of roots which possible, then there are some values which are not possible even the terms of our expression, right?
Right, ma'am.
Yeah, correct. So this is nice question. Okay. So the method is simple. Just try to convert into polynomial. So there are 3 steps. Okay. First step is try to convert into polynomial. Second step is find the root. And third step is ask the question, can we find some x such that if I suppose some f of x is equals to t, so can we find an x belongs to real number such that our f of x is equals to the root of polynomial. So these are the 3 crucial steps you should know when you solve this question. Okay, fine. So you got it?
Yes, ma'am.
So yeah, someone says they have doubt in something.
Yes, ma'am.
Yeah.
Ma'am, that topic, ma'am, just a second.
Which topic?
Ma'am, just a second.
Sorry, I am not able to hear you.
Ma'am, 1 minute.
Yeah.
Ma'am, that limits for sequences topic.
Limit of sequences, yeah.
Ma'am, I have doubt there.
What type of doubt? I mean, you are not able to understand what is the limit of sequence or something else?
Ma'am, that limits for sequences only.
Okay. So, you know what do you mean by sequence, right? Sequence is just...
I'm converging and that diverging one.
Yeah, convergent and divergent one. Okay. So, suppose you have a sequence an, and this an goes to a single number a, unique single number a, more closer and closer to a as our n goes to infinity. You understand this meaning, right? What is the limit of a sequence?
Yes, ma'am.
That means simply as we put larger and larger values of a, we should be able to get something which is closer and closer to a. For example, if I have a sequence an, simply what I can take, okay, 1.11, again 1.1111, again 1.11111 in some sense. So if I'll take my limit a to be 1.2, sorry, 1.1 something, then as we approaches to as it goes to infinity, the sequence will look similar to a, right? It goes nearer and nearer to a, not exactly a, but closer and closer to a, right? For example, this sequence 1 by n. So 1 by n goes like 1, 1 by 2, 1 by 3, 1 by 4, and so on. So that means if this is my 0, what I am doing? So I am first step is my 1. Then at second step, I go more closer to 0. And then at a third step, I go again more closer to 0. And again closer and closer to 0, closer and closer to 0. Eventually, I know that I won't exactly get 0, but as my n goes to infinity, I will go more closer and closer to 0. That much you know, right?
Yes, ma'am.
So then convergence and divergence is nothing but we are given two situation name. If you have a sequence an and if our an converges to a single limit, then we say that this sequence is convergent. And if this won't happen, then we say that it is divergent. So this situation is known as convergence. This situation is known as divergence. Then we say our sequence is convergent if there exists a unique single number a such that as our n goes to infinity, we can get more closer and closer to that number. Right?
Yes, ma'am.
Now you got it?
Yes, ma'am. Thank you, ma'am.
Yeah.
Ma'am,
So
I have
convergence. Yeah. See.
Ma'am, I have one question related to it. Can you please take that?
Yeah.
I'm pasting in that chat box.
Okay. Yeah, it's easy question, okay?
Ma'am, I haven't sent yet.
Yeah. It's loading actually. Okay. So choose the set of correct options. So there are. So what is your question here? You have given 4 curves. In this curve, what you have to decide?
Ma'am, I think it's my question. Because question is different.
Okay.
She
Okay,
shared
so,
latest
yeah. This is your question. If an and bn be two sequences such that mod of an is less than equal to mod of bn for all n is greater than equal to m, then m belongs to n. If n goes to infinity, bn goes to 0, then find the limit of n. The limit of n will be 0 again, right? Answer should be 0. I mean, here you are using sandwich theorem somehow.
Like, is there any other way to do this question without sandwich theorem?
Let me think. If we have an and bn, such that mod of an is less than equal to mod of bn, and you know that limit n goes to infinity, mod bn goes to 0, right? This is the condition.
Ma'am, in this question, I didn't understand what is m. Because m is not used anywhere. Then suddenly m comes to the question.
Yeah, fine. Where m belongs to nature. Yeah, fine. I'll explain this, okay? Actually, this is a little bit typo for you. Sorry, what?
Ma'am, that means it should be greater than or equal to natural numbers, no? That's why m is given.
No, it's
Ma'am,
not.
I think m is used in the number.
I mean, what they are saying that such that mod of n is less than equal to mod of bn for all n is greater than equal to m, where m belongs to natural number. I mean, first what happened now? You have, let me explain it. Okay. Suppose you have this sequence, an is equals to, suppose -1, 5, 9, 10, again 9, 10, and 11, 11, 11, again so on 11. Suppose this eventually it is 11, okay? But here are some other numbers, and you have bn to be 0, 4, 8, 5, 9, and again 12, 12, 12, and so on, right? So here you observe that mod of an is less than equal to mod of bn for all n greater than equal to which index? 1, 2, 3, 4, 5. 5 terms are giving us trouble. So what we'll do, we'll just exclude them. Greater than equal to 5. So that's the m is doing here. I mean, the m is saying to you that eventually this condition is happening. I mean, there are some terms in the preceding of the sequence, as if here, these 5 terms are not satisfying this condition, right? Because 1 is not less than equal to 0. If we take a1, mod of a1 is not less than equal to mod of b1, right?
Right.
So these 5 preceding 5 terms making some difficulties for us. So what we can do, we can simply remove it, because finitely many terms won't contribute in the limit. In the limit, what we want, as we go to the n goes to infinity, then we want more and more closer to a or b, right? So if you leave some finite terms from the beginning of sequence, it won't affect the limit of sequence, right? Eventually this sequence converges to 11, and eventually this sequence converges to 12. These finitely many terms which are appearing in the beginning of the sequence won't contribute anything to the limit, right?
Okay.
Getting my point?
Yes, ma'am.
So that's why they have written there that this is happening for all n is greater than or equal to m, where m is some fixed natural number. Here in our case, m is 5. That's why they are written there. Okay. So again, we have a question that what is limit n tending to infinity of en? So it is 0 by sandwich theorem, obviously, because mod of en is less than or equal to mod of bn, right? So this means that minus of bn is less than or equal to mod of en is less than or equal to bn, correct? And this goes to 0, this also goes to 0, because we know that limit n tending to infinity, bn goes to 0. So if bn goes to 0, then limit n tending to infinity minus of bn v goes to minus of 0, but minus of 0 is 0 simply, right?
Yes.
Yeah. So other than sandwich theorem, I don't know, because we haven't given an and bn explicitly so that we can work with an. We all have dependency on bn. We should, I mean, anyway, we have to use these two conditions, right? Anyway, we somehow to use these two conditions to get the limit of n. So I don't think other than sandwich theorem we can make it. But whenever you find such an inequality, there is only possibility of sandwich theorem. I mean, you should remember, if you are given that two sequences are having some inequality, try to apply sandwich theorem. Sandwich theorem is most, I mean, such a powerful result, so cannot skip it. Now you have any doubt? You know sandwich theorem, right?
Yeah, ma'am. It says that if the two, like,
yeah, it's simply graphically you can assume. Suppose this is your sequence, this cross points are your sequence, right? And these cross points are some another sequence bn, and these cross points are some another sequence cn. So eventually what is happening, that these two cross points are bounding this black one. So that's why they call it sandwich.
Okay, ma'am. Ma'am, I have pasted one more question. I have a doubt in some options over there.
Yeah. So what is this? Which of the following options is are true? So decreasing sequence, increasing sequence. Okay. So which option do you have doubt?
Last one is clear, but
last one is clear. Yeah. Last second.
It will cancel, so only root 1 will be left. That is 1. So 1 will be a constant function.
No. What are you saying?
And that root n plus 1 minus root n. So I solved it. I don't know whether that is correct or not. Like I cancelled root n and root n will be cancelled out.
No, that is not correct now, because just think about this way, that 2 plus 1 minus root 2. What is this? This is root 3 minus root 2, right? And root 3 minus root 2 is not equals to 1. Just calculate, and the calculator is 7.372 something, or this is 7.414 or something. This won't be equal to 1. So you cannot do in this way, that root n minus 1, root n plus 1 minus root n. This is not equals to 1. Right? Okay, so This is not true. We cannot cancel it. But in this case, what we will do, n plus 1 minus 1, we can use multiplication and division by some another factor. I mean, this is root n minus 1. So I'll multiply it by root n plus 1 plus root n and divided by root n plus 1 plus root n. That will give me something n plus 1 minus n by root n plus 1 plus root n. I don't think it will help for deciding it is increasing or decreasing. But eventually we know that root n plus 1 plus root n, this is less than equal to root n plus 2 plus root n plus 1, right? Because here we are adding some lesser term and here we are adding some bigger term. Obviously root n is less than equal to root n plus 2. So then this will implies that 1 upon root n plus 1 plus root n is greater than equal to, because when we flip our terms, the inequality will change, right? Because we know that 3 is greater than equal to 2, but 1 by 2 is greater than equal to 1 by 3. So that means we are flipping the quotient and the numerator. So our inequality will also get adjusted according to them. So it will become that under the root of n plus 2 plus under the root of n plus 1, right? Okay. So we have this term to be an of our sequence, right? Right or not?
Yes, ma'am.
So this is your an is greater than equal to, and this will become your an plus 1. Because in terms of this can be written as n plus 1 plus 1, right? So from here you get that this is a decreasing sequence. So this is more I mean useful way to do this type of questions. Okay.
Ma'am, can you explain how did you get after getting 1 by square root of n plus 1 plus n?
1 by, yeah, we get this, right? Then we know this inequality that under the root of n is less than equal to under the root of n plus 2. Because obviously n is less than equal to n plus 2 because we are adding something in n, right? And we know that the root function is increasing, right? So this is the root function, right? This is under the root of x. So this inequality is clear to you?
Yes, that inequality is
ma'am.
clear.
Yeah. So just observe here that this is one term.
No, but before that, how did you get this one? You just took two terms and you're just comparing.
Yeah, because I somehow compare an and an plus. I somehow want to compare an and an plus 1, right? So I know that my an look like this. I know my an plus 1 look like this. But I observe here that this term and this term is common in the both of the values, right? So the matter of fact is just root n and root n plus 2.
Okay.
So then we know that, okay, fine, this is less than equal to this. So we reach here. And from here from here to an, we just have to flip it down, right? So that's how we get. I mean, it require practice. It won't click instant in, but this is, I mean, trivial. You can use that facts also. Whenever you want to describe a sequence is increasing or decreasing, what is your motive? That you want to find a relation between an and an plus 1, right? Either it is greater than equal to 0 or it is less than equal to 0 or none of them, right? Right. So yeah, so it is better sometime just write it down what is your an plus 1 and an, and then try to observe that, okay, fine, we can find a relation or not. I mean, it requires a little bit practice, but it can be done. Okay. So this option is clear to you, right?
Yes, ma'am.
I guess the second one is also clear. It is decreasing 1 by n. So 1 by n is increasing, minus 1 by n is increasing. Yeah, the second one is correct, right?
Yes, ma'am.
And it is also clear because it's just 1 by n type of sequence, right? Or should I do it?
Ma'am, could you do that, please?
Which one?
The second one.
The second one, yeah. Minus 1 upon 6n minus 5. So just we are using some fact. I'm doing some. You can check. Yeah. So second one says that minus 1 upon 6n. 6n plus 5. 6n minus 5. 6n minus 5. So I want to find it is increasing or decreasing. Okay. So again what we want. So what is an plus 1 here? So an plus 1 is 6 into n plus 1 minus 5, right? Minus 1 upon this thing, right? This is same as minus 1 upon 6n plus 6 minus 5. So plus 6 minus 5 will give us plus 1. So this is your an plus 1. Now what is your an? So an is 1 upon 6n minus 5. And now we know that 6n minus 5 is always less than equal to 6n plus 1, right? Because this is something minus we are taking. And this is something we are adding. So that means we are moving forward and here we are moving backward. So obviously this quantity will lie before this quantity. I mean, some you can observe this, that this is your 6n. Your 6n plus 1 will lie some here, 6n plus 1. And your 6n minus 5 will lie here. So that means this is less than this, right? Okay.
Yes, ma'am.
So 1 upon 6n minus 5 is greater than equal to 1 upon 6n plus 1, right?
If n is positive, no ma'am.
Yeah, but in case of sequence, we always take n to be natural. So we don't have to worry about it. N is always positive, okay? Don't worry. And if you multiply by minus sign, our inequality will again get changed. So it is minus 1 upon 6n plus 1 is less than equal to minus 1 upon 6n minus 1. Minus 5. And this is the value of an plus 1. So an plus 1 is less than equal to an. Got it?
Yes, ma'am.
So in general, first evaluate what is your an plus 1. Then evaluate an. Observe the term, whatever inequality you can get. Okay, I can compare these two terms, right? 6n minus 5, 6n plus 1. So just compare it and then try to reach back to your an and an plus 1. That's the process.
But ma'am, here, when you change the inequality, you should not change the position of these two, right?
Yeah, I have changed the position. Yeah, I have changed the position. Yeah, correct. Now it's correct?
Yes, ma'am. So now if that is true, then n plus 1, n plus 1 is, so this is, this is true.
Yeah.
That means as we are increasing, the sequence is also increasing. So it's an increasing sequence.
Yeah.
Okay. So, yeah, correct. You're right. So this is clear, right?
Yes, ma'am.
Now go to first option. What is the first option?
3n minus 5
minus 5 again.
By 4n plus 2.
4n plus 2, right? Okay. So now we have difficulty here because we cannot compare straightforwardly, but yeah, we can do this. In this case, just try to compute what is an plus 1 minus an. This is 3 of n plus 1 minus 5. Because what we want an plus 1 less than equal to an. So, or whatever this is, an plus 1 is greater than equal to an. So that means we just want an plus 1 minus an is less than equal to 0, or an plus 1 minus an is greater than equal to 0. So it is always helpful to compute an plus 1 minus an. That will also help. So just compute an plus 1 minus n. 4 times n plus 1 plus 2 minus 3n minus 5 by 4n plus 2. So now this is equals to 3n plus 3 minus 5, so minus 2, I guess. And 4n plus 4 plus 2, so 4n plus 6. And minus 3n minus 5 upon 4n plus 2. Okay. So at the end we get 4n plus 6, 4n plus 2. And just multiply here. So that will become 12n square plus 6n minus 8n minus 4, I guess. And the minus of n 12n square plus 18. Okay, so minus n, I'll take it out. So 12n square plus 18n minus 20n and minus 30, right? I think so, right. So this is same as 4n plus 6, 4n plus 2, and minus n is there. So 12n square and 12n square will get cancelled out. We get 6n minus 8n. So what is it? Minus 2n, right? And here also we get 18n minus 20n. So again minus 2n. So minus 2n also get cancelled out because of this minus.
Right.
Right. Okay. Now we have here minus 4 and here we have here minus 30, right? So it becomes minus 4 plus 30, right? So this is equals to 26 upon 4n plus 6 and 4n plus 2. Now you observe here, whatever natural number you have take, this quantity will also remain always greater than equal to 0, right? Because just addition and multiplication of positive number, right?
Yes, ma'am.
So at the end, we get an plus 1 minus an is greater than equal to 0. So that means an plus 1 is greater than equal to a. So this is one approach for finding our sequences in increasing or decreasing. That you can just try to compute what is the expression for an plus 1 minus an. And from there, you can get some intuition, okay, this term is always positive or negative or something like that. And then you can get it is increasing or decreasing. Okay. Fine.
Okay, thank you, ma'am.
Oh, itni tarif. Okay, fine. Now, anyone has doubt? Any other doubt? Any other question?
Ma'am, can you take my question?
No.
Ma'am, I have one doubt.
Yeah.
Ma'am, I have posted in the chat.
This graph one?
Yes, ma'am. Ma'am, how can I find where the derivative of function is same? By using the tangent.
Where the derivative of function is what? Same?
Same.
Same.
Yes, ma'am. In the option it says in the curve one, there are 2 points where the derivative of function is same.
Yeah.
So I'm not able to get how they say the derivative of function is same at 2 points.
And there are lots of points where derivative of function is same. I mean, you can observe there are 2 minimum points and 1 maximum point in the first graph, right? I mean, the first graph is, I guess, the graph of cos. This is the graph. Okay? Sorry. This is the first graph, right?
Yes, ma'am.
Whatever this is. Okay, so this is graph of cos, right? In the graph
Yes,
of cos, so its derivative will be sine. And we have to find the value of sine, what in which domain they have defined it.
Just taking since it's a tangent, right? Just taking any point in if you draw a horizontal line anywhere, and as long as it cuts the same point, the slope would be the same, right? Or slope of the tangent on the same side of the curve would be same. So it's a wave, right? It keeps on repeating. It keeps on repeating, right? So at same point, say for instance, I cannot show you.
Okay, the question. What is the question? Repeat again.
At least there are
each
2 points on curve 1 which have the
Mhm.
same slope, essentially, same derivative, right?
Same derivative, na? So
Same
there are
slope, right?
Yeah.
Same derivative means same slope, right?
Yeah.
Yeah. So if you take a point here, just where this y-axis cuts or this line cuts, right? The vertical line. And if
Yeah.
you go parallelly to that one
Yeah,
after
they have
one
the
base, then it
same
would be
slope.
same thing. Yeah.
Yeah, there are. That's why I'm saying that there are so many points where the
Right.
slope of tangent is same. I think the question is in. I
Ma'am, I
mean,
paste the question, ma'am, whole question in the chat box
yeah,
after
just
the
paste the
this
full
one.
question, okay?
Sorry, ma'am.
Yeah, fine, fine. So there are at least 2 points on curve 1 where the derivative of function corresponding to curve 1 are equal. So this is a correct option, right? So there are at least 2 points on curve 1 where the derivative of function corresponding to curve 1 are equal. Correct, because we can easily find what Abdul was saying, that if we move this curve parallelly, right? So this, suppose we are moving this curve parallelly. So what happened? At this point, we have this type of slope, or similarly at this point, we have this type of slope, because the function is what you can say periodic, right?
Yes, ma'am.
So there are so many points where the function have the same derivative. So the first option is correct. Now you got it, why it is correct? Because it's just
Yes, ma'am, I got it, ma'am. Means
the cause
after
was,
some time the same value is repeated because the graph is
yeah,
periodic.
yeah, correct.
Yes.
So first option is correct. At the origin, the derivative of function corresponding to curve 2 does not exist, because there is a some uh, uh, I mean
Sharp point.
at 0,
Sharp
yeah,
point.
sharp point. There's some sharp point at 0, so that's why derivative won't exist. So second option is also correct. Now third option says the derivative of the function corresponding to curve 3 at the origin and at the point -1, 2 are same. Okay, origin and -1, 2. So origin -1.
Origin means 0
It's
and
0. Yeah, at origin it is 0. And what is the other point? -2,
-2, 0.
So that's not correct, because at origin the curve is something like at origin the curve is something like this, right? Suppose this is your origin.
Yes,
So
ma'am.
here derivative is 0, but at -2, 0 this is decreasing. So obviously this is not same, right?
Yes, ma'am.
Okay, and the last is the derivative of function corresponding to curve 4 does not exist at any point. I think that's also not correct, because it is smooth even though some points. It is a constant function, so derivative always
constant.
exists at every point. Yeah.
Yes.
That's your question. Fine.
Thank you, ma'am.
Okay. So I will list it out some important topics, what you should just recall. First is the relations. Whatever relations you have studied, antisymmetric, symmetric, transitive, equivalence relation, those relations. Second is polynomials. In polynomial, the whole topic, I mean, zeros of polynomial, multiplicities of zeros, increasing, decreasing, right? Even odd polynomial, and even function, odd function, that's also included, right? Polynomial, in polynomial, even function, odd functions. Then third is the domain of function. And what do you mean by one function? What do you mean by onto function? That means bijective function itself. So this is the third topic. Fourth topic is, yeah, obviously you will see some logarithmic function. I mean, yeah, log, exponential, those two will be there. Domain of composite function. And the third topic is limit, continuity. I mean, I'm listing the whole syllabus, but yeah, differentiability. Limit, continuity, differentiability, just try to observe where it is not continuous. I mean, use the basic definition. Left hand limit is equals to right hand limit. Okay. In continuity, use this thing that left hand limit is equals to right hand limit is equals to the function value at that point. And differentiability is also, you know what, you have two definitions for differentiability. That limit h goes to 0. I mean, you know that f dash of a is nothing but limit h goes to 0, f of a plus h minus f of a by h. And the other one is limit limit z goes to x, f of z minus x, f of x by z minus x. These two definition will serve parallelly. So just observe it. Okay. So what is your question? That, yeah, same kind of question what the Bhumika have posted here. These type of questions also you can assume in the exam, because they are a standard type of question for limit and continuities. Okay.
Ma'am, can you please take that? I don't know. I have a doubt over there.
This question?
Yeah, ma'am, this last question.
Yeah, okay. So first option says that the left limit at x is equals to 0 is 0. So whenever we talk about left limit, what we will do? We travel through graph from the left hand side, right?
Yes.
So here, if you travel through graph from the left hand side, at which point, of which point more closer and closer you will get?
Ma'am, 0.
Yeah, right, 0.
Ma'am, but I have a confusion. I'm getting confused with the like open circles and the closed circles. I don't know why, ma'am.
Closed circle means the function is defined at that point. That means f of 0 is equals to 0. And if it is open circle, so that means the function is not defining exactly at that point, but it is defined everywhere around in a open, around that point. For example, here 0, at 0 the function is defined to be 0, right? Because there is a closed ball, right? And the open ball is on 100. So that means where if I'll take 0.001 or 0.0000001, so value of function at this point is 100. That's the meaning of closed ball and open. Exactly at that point, the function takes values where the ball is closed. I mean, the ball is the whole black. And the hollow ball will say that whatever value will come after 0, slightly if you displaced your point x from 0, then you get the value, function value will define to be 100. That's the meaning of those 2 points, right?
Okay, ma'am.
You got it or still have confusion?
No, ma'am, got it.
Yeah. So that means whenever dark point is there, the function exactly attain that value. And if you displace little bit from that point, the function will attain the other value, whatever defined it is. The hollow point. The hollow point. Got it?
Yes, ma'am. And
yeah.
Then limit exists at x is equal to 2. So
yeah, limit will exist at x, because in a neighborhood of 2, if you travel from the what you say left hand side, you will reach at 0, right?
Yeah, ma'am.
And from the right hand side also you will reach at same point. So that means the limit at x is equals to 2 exists and it is equals to 0. So limit at x is equals to 0 is 0. That's not correct. Limit exists at x is equals to 1. That's also not correct, because from the right hand side you are approaching something else, and from the left hand side you are approaching 100, right?
Ma'am, that limit exists at 0 will be false.
Yeah, it is false.
Because LHL we are getting as 0. That left limit.
Yeah, and the right limit is we are getting 100. Why it is say that accepted answer is left limit? Yeah, left limit at x is equals to 0 is 0. Not limit exists at 0. Yeah. First option is true, sorry. Yeah, first option is true. Second option is false. Third option is also true, because at 2 you get your things. And the limit at x is equals to 0 won't exist. So fourth option is false. fifth option says that limit exists at x is equals to 1 by 2, which is 100. That's also correct, right? Because at 1 by, in a neighborhood of, or in the nearer point of 1 by 2, the function is just attaining the constant value 100, right? Right?
Yes, ma'am.
Okay.
Ma'am, there is not a dark circle. How it can be 100?
Yeah, but 1 by 2, it is given that it is a constant function. From, I mean, it is, this is the graph, right? This.
Ma'am, but it is stopping before 1 by 2 now. That
Yeah, 1 by 2. You just take small neighborhood. You don't have to go for so large things. Just take little bit small neighborhood. And then at that small neighborhood, it is constant, right? If you take a small interval containing 1 by 2, then the function is constant on that interval, right? It is clear or doubt? You have doubt?
got it, ma'am.
Ma'am, one doubt.
Yeah.
At x is that at 1, no? What is the right hand limit?
The right hand limit at 1
will be 1 or 0. What will it be?
Right hand limit is something else. It is not exactly 0. It is something more than 0, because the black point is above the x-axis, na? So,
so it's
we
not
don't
0.
know exactly, but it is basically not 0.
But less than 100, no?
Yeah. So at 1 by 2, what is happening? Whenever you concern with the limit, you just have to deal with the smaller section. Take any smaller section of 1 by 2, and from that smaller section, move from the left hand side and move from the right hand side. So here at this smaller section, your function is just constant, nothing else, right?
Yes, ma'am. Got it.
Yeah, fine. Okay,
Thank you so much,
so
ma'am.
yeah, thank you so much. But I have to end this session here because I have to go now. I will share the PDF, whatever, and we will also have one session before the quiz. Basically, after the mock test or before the mock test, they will inform you. So I'll share the PDF and then you guys can leave. Okay. Fine.
Okay. Ma'am, please share in chat.
Yeah. I'll share exactly.
Thank you, ma'am. And
Welcome.
Thank you.
Ma'am, session PDF only, na?
Yeah, session PDF. Whatever today we have discussed till now, whatever. Although don't bother about exam that much. I mean, you have done so many things, you have done so many examples. Just revise it properly and don't mug up the question. Just try to understand what are the ideas you have applying in this question. The same trick or same idea will also apply in the similar questions also, right?
Ma'am, so there will be session, one more session for quiz 2.
Yeah, one session, I'll try to schedule it for you. I mean, you guys are saying you want some PYQ session, so we can have it.
yes, ma'am.
It may be
Some PYQ.
Yeah, sorry.
Yeah, some PYQ, more PYQ sessions.
Yeah. Okay. Fine. I have shared the video. You can leave the meeting now.
Okay.
I'll share tomorrow my LinkedIn profile. Okay.
Ma'am?
Yeah.
Yeah. Ma'am, I have a good question about differentiability derivative. So
related to what?
As if we differentiability.
Your voice is breaking.
Hello.
Yeah.
Hello.
Yeah.
I have a quick doubt about the differentiability and the derivative.
Okay.
So if we are given a function in the closed interval, so in that book, Thomas book, in that they are given the function is differentiable at closed interval AB, then we can just simply say it is differentiable at the all the point between that between those 2 points, right?
Yeah.
And I have just asked the question in the beginning. You have just presented that the random graph one.
Yeah.
So what can we say about the endpoints of that function?
Actually, it depends. I mean, some people won't bother about endpoints regarding to differentiability because they are tough to handle. I mean, in Thomas Brook, they have said that if right-hand derivative will exist at any of the endpoint, the function will be differentiable. But in our case, we won't assume that. At endpoints, we won't say that our function is differentiable. Okay. In the preceding graph, there is no endpoint because the function is going plus infinity and minus infinity. But if there is an endpoint, then you should not assume that the function is differentiable at that endpoint. Okay.
Okay, so we have to just leave whether the function is defined on that point or not. We can just leave that point and we can just talk about the inner points for differentiability.
Yeah.
Yeah, okay. But when we talk about the tangent, so that is also the derivative of that function.
Yeah.
But we can define the tangent at that point.
No, we cannot
Like
define the tangent at that point. No, that's the point. Because at end point, there are so many tangents. You can have so many tangents. I mean, don't bother about endpoints till now because we haven't given anything. I mean, there are two different concepts. There are two different, what you can say, thinking of close interval 0, 1. So I will suggest don't bother about those two endpoints because in our case, we don't want, because at endpoint, you can draw any line to be a tangent, right?
Yeah, right. Yeah, okay. So for this note, if we are given that function as it is, that endpoints is defined, value is defined, and we are given the two statements, whether the function is not differentiable at the endpoints, and the second statement is we cannot say anything about the not differentiability or differentiability of that function. So which statement would be the correct? Not
Just say
differentiable, or we cannot say anything?
we cannot say anything because there are two other things. I mean, there are other concepts which we'll use for endpoints. First is this left or right hand derivative, which I already told, right hand derivative, left hand derivative concept.
That one is the basic.
But we haven't discussed anything about endpoints of the function, right? So I'll suggest just say that we cannot talk about differentiability there.
Yeah, as like we just say if the function is not defined at that point, so we cannot talk about the continuity of that function.
Yeah. No. Wait. What?
We are as the one of the student as like if we just pull out the one point from the graph and make it whole at that point, and we are not defining the function's value at that point, like the whole graph we are given, and for let's say for x equals to -2, we haven't any value of that function. So we cannot talk about the continuity at x equals to -2 because we are not given the function of value.
Yeah, because for continuity we want f of a. If you don't have f of a, you cannot talk. Actually, I have to end this session. I have to go somewhere. Okay, so we'll meet after. Okay, so I have already shared the PDF. So thank you. And don't share my mail ID. Okay. So I will share you email ID. I mean LinkedIn ID after that. Okay, fine. Thank you. Good night, everyone.
Okay. Yeah. Good night.